There we go. So yeah, fold the edge onto the diagonal of the square. Now, last class we looked at the golden rectangle. And that is one of the divine triangles of view, one of those that has a very special proportion to it. The one we're going to do today also has one of those special proportions. We're going to unfold the first fold we did, this diagonal of the square. Have it like this. Now, just as a side note, if you're using A4 paper, this fold should actually hit exactly on the end of the edge of the square. So if you're in Europe or any other places, not the United States or America, really, this should be lined up right there. And now the fold we want is where this fold hits the upper edge. On this point, we want to draw a perpendicular line to the edges, to the top and bottom edge. So to do that, I'm going to turn my paper over, like so. The fold is back there. And now I'm going to lift the paper up. And as I lift it, I'm going to see that it's going to hit the fold. See? It hits it. And so when it hits, then I pivot. And I make sure that this bottom edge lines up. You know, the edge lines up with itself. I see a comment that says repeat. So, okay, if you're here, just cut this off and I'm going to do it again. I'll do it over. We start with our rectangle. We fold our diagonal. So if this were a square, if the short length would be unit length, so let's say that this is 1. Let's say that from here to here, that's 1. I'm not even going to write it down because I'm going to cut it, but let's just say that this is 1. And so what we've done here by doing this fold is we found where from this corner to where it's also 1. It's pretty much what we've done. So we know that from here to here is the same as from here to here. And so we have this fold. We're going to turn it over. And then we fold the outer edge, the long edge of the rectangular paper. And we fold that onto the diagonal of the square. The fold we just did. Pretty simple. And then we unfold it. At that point, we lift, we hit, and we descend. Making sure that the edge lines up with the edge there. Making sure that this point also is exactly at it.
Can you just go back one step, please?
This here?
Okay. Oh. Okay.
So this was the first one. So first step of all this was
yes.
Square. Then I turned it over.
Oh, okay. I see. Okay.
And then I get the long edge of the rectangle and put it on the fold. So if you have, I have letter size paper, but if you have A4 paper, this should exactly match. Like this should fall exactly at the end of the paper. And see, the reason for that is that A4 paper has a proportion of 1 to √2. And because the diagonal of the square, according to the Pythagorean theorem, is √2, when we take the edge and put it on there, it should be congruent. And that is, they should be equal. So if one were so inclined to turn a letter size paper into A4, at that point, you would need to draw a perpendicular, where this edge hits the fold right there. Boom, a perpendicular line that goes all the way down just like the one we did over here, but instead of installing it here, I call it installing. You can call it whatever you want, right? And if you put a perpendicular here, instead, put it over there, A4 paper, A4 proportion paper, A proportion paper. See, the reason why they use that proportion is because if you cut it in half, you would get the same proportion in that sort of segment. So that's great for propaganda because you would just have to print out one sort of design and just cut it all in some sort of square grid. You would be able to retain that ratio. So it's quite practical for printing, and nothing says mass printing like propaganda. So that fold we did, where we put that on this line, where this hits, we folded this perpendicular, right? Because we had this folded, and then we see that, and then we lifted that up where it hits.
So we fold where it hits, not necessarily in half.
Exactly, no, where it hits.
Okay, I see.
And then this fold we just did, we will cut it away. This is gone. So, one is inclined to think, well, of the Europeans, because I think it came from Europe, this sort of proportion paper, were so, where they have this reason for their letter size, their paper size, then what about the Americans? Where did they come up with this letter size? And the answer to that is their typewriters. It's actually sort of like they didn't really care about the size of the paper, they cared about the size of the machine. They were more focused on the typewriter. So actually the size is based on the size of the typewriter, not the other way around. Ain't that funny? This we have right here. This is called a silver rectangle. It is a metallic rectangle, as well as one of the three divine rectangles, as I call them. So it goes for the metallic, they go golden, silver, and then bronze. But see, the thing about the metallic rectangles is that what they're doing is pretty much having a rectangle which has n number of squares, and then having a segment which also has that n number of squares, and a segment that also has that n number of squares, and a segment that has that, and so on and so on and so on. So the golden does that with 1, silver does that with 2. So let's see how silver does that with 2. We have this one already folded there. Now we're going to take the opposite one, just to keep things like simple and cool and nice. We're going to take this one and fold it down onto the bottom edge like that, and make a little rhombus thing. So what I'm saying is that, well, if this has 2 squares and then a segment that has 2 squares, the segment right between these, this segment right here, this should be also a silver rectangle, which means that within it, we can draw another 2 squares. And inside there will appear another silver rectangle, in which inside we can draw another 2 squares, and so on and so on and so on. So if we wanted to sort of use this and see it happen, well, what we can do is we can see how this is coming down, and then it's going to hit. And so what we want is where the square sort of is going to meet. So what we can do is we can just take this and just raise it up and match it to the other one. You can take that down. Oh no, it was the other way, sorry. It's like this. This time I'm going to use the camera on the computer. I'm monitoring my movements.
Please repeat the last step.
The last step? Well, no, technically we're just trying to draw in these sort of crosses here that I've done in. Because we want to see the spiral happen. So now we need the fold that goes from here to here. So if you want to draw this line that goes here to here, what we want to do is we want to take this edge and then put it down, because see, it's going to go 1 and then bounce off 2. So it's got to come down there. So after this demonstration, after I show you these steps, I'm going to show you how to do the sort of the geometric deconstruction of it. If you're familiar with Islamic patterns, this figure should sort of pop out at you. You can see that this is what they call the torso, right? And then this is sort of like the petal, right? You sort of see there. So this shape comes up a lot in the eightfold Islamic patterns. But anyway, we can also then fold this back. If you wanted to sort of limit our silver rectangle inside the silver rectangle, which is pretty much like the object of this exercise, is sort of to see how deep this goes, which is infinity. So infinity is not very encouraging in the sense that, you know, if it goes on forever, why can't it just stop after the third one? What's the difference between 3 and infinity, right? I get it. And just keeping with the tradition of what we were doing with the golden rectangle, we want to cut right here. And what I mean by that is you sort of want to see the spiral. So that means that I'm gonna sort of want to have loose squares for these. Just gonna go hit there. Just gonna go hit there. And so you notice how I've also folded these lines down here. So I folded this and hit there. And this line I'm drawing in right now, I'm gonna cut away because I want this to sort of fall down like I did before, like, but all in one movement. So I'm just gonna cut this line away. Until I hit there, until I hit this, and I can sort of tuck it now. Now the cut is gonna occur here, so we can sort of like start to take this down. Let's see the same logic now. I'm gonna sort of take this down. It's cool if you have an X-Acto knife because now you can sort of see where the line is hitting the edge there. So that would be what you need to cut. Just so you can sort of, well, no, because then it's sort of separating it. No, then it would go all the way. Yeah, then it would be separated. No, it wouldn't be separated. It's pretty interesting. I don't know why, but I get a kick out of this sort of, well, how would you say it? I guess it would be sort of like questioning the infinity, I guess. I don't know. It's weird to call these things names, but.
Can you just go back to the last cut? So you cut on an, oh, okay, I see.
Yeah, so I actually went down all the way until it hit the other square.
Okay.
Because I have to lift this little hinge here.
So then cut back in again. Okay, I see. Okay, thank you.
So what's cool about this is that we won't actually get to have two separate pieces of paper. So if we keep respecting this sort of construction we're doing, they would always be joined And there would always be a little segment there that keeps it together. And so this is the other sort of like divine spiral. They don't write books about this ratio for some reason. Like they write books about the golden ratio and how it shows up in nature. But this one shows up in nature. There's probably like a galaxy out there that has this spiral happening.
Okay.
And you can even see this with your hands. So if you want like a happenstance in nature of this, you can just go like this. I don't know why I always like whenever two spirals sort of like join sort of around the point, sort of like this. You know, I sort of think about it. It reminds me of this one. I wouldn't go as far as to say it has the same ratio, but you know. And so on and so on and so on. So this is sort of like the depth of the silver rectangle. That's the idea of this thing. But if we sort of, I'm going to put this aside for a second here. And I'm going to do the other one I have just to sort of demonstrate the geometry of the thing. Once the geometry is demonstrated, I'm going to show you some of the constructions I did with the silver rectangle, sort of get you on track and play around with it. Because it has infinite potential, see? And the more you fold it and the more sort of like you relate it to itself, the more of its relationships are going to be useful to you. So I said that this was the silver rectangle, and then I said it was related to the root 2. So exactly what is happening here? So the silver ratio is 1 plus root 2. And so there's actually, okay, so I'm going to just open up real quick here my browser. Wait a minute, I have a chat thing. Oh, please audio off, yeah. Metallic ratios. Because there's a formula to get the metallic ratios, but it breaks off after the bronze, after metallic means. Let's see, yeah. So metallic means is n plus the square root of n squared plus 4 over 2. So n is how many squares you want in your rectangle. So this will yield the golden ratio and the silver ratio, but it will not yield the platinum ratio. And the platinum ratio relates to 12-fold symmetry. So golden ratio relates to pentagonal symmetry, silver to octagonal, and platinum to 12, but bronze relates to nothing. Okay, so except to having 3 rectangles. So, okay, so let's plug in 2 to this thing. So 2 plus 2 squared, that's 4. That's 4, so that's 8 over 2. So 2 plus the square root of 8 over 2. And square root of 8, we can also write it as 2 plus 2 root 2 over 2. Right? So we can just simplify this to 1 over 1 plus root 2. Just divided by 2 everything, so So 1 plus root 2. And so that means, well, we have 1, and we said the root 2 was the diagonal of the square. So conveniently, we have here a diagonal of a square, we have a square. So if you know it matches to reason, then everything that's left off after it should be exactly that. So let's put it to the test. And lo and behold, there it is. A silver rectangle. So what I'm saying is that if this is 1 and this is the square root of 2, right? Because it's the diagonal of 1 and 1. And then I take whatever's left off and I put it on there, and I see that this line is also root 2. So I put them together. It's 1 plus root 2 because they're collinear. So I can just add them up, right? And so this is, and well, because this is the same, then this would be 1. So this rectangle, if we had another one like I have here, and I put it like this, sort of like match them up to be just right, they would actually show me, well, this line and then this line, sort of like, well, yeah, let's complete it, I guess. Why not? Just to demonstrate. No, it's a little high. Yeah, this would be an octagon. That's the idea. This would be an octagon. So this rectangle is inside the octagon. Curiously enough, the golden rectangle is not inside of a pentagon. You can find the pentagon inside of the golden rectangle, but not the other way around. So, you know, this is pretty much like the idea of it, right? But that's also why it's so deep in its properties, this thing, because it's just within the octagon, but at the same time, you can find it in itself and just keep going on forever. And this is exciting because really, if you had a big enough side of paper and enough determination, you could keep this going and it would never fall off. You know, it would never break or be separated. There will always be something there, some small thing keeping it together. And these ratios, these sort of descending and smalling, becoming sort of rectangles that appear there, could also relate to an Islamic pattern, so the scale of it. So for instance, this is also a silver rectangle. And the idea of this is that, like for instance, this point and this point are centers of a star. And, you know, I guess it's more than that, but let's see. Let's fold it a little bit, see the lines of the folds of the pattern and see what happens here. I have this one, doesn't relate to much. Have this one, well, that's the square. So we have these lines are this square. See if the other one does not. What about here, this? That one hits the bottom of that star there. Well, there's a bunch of relationships, and I'm not gonna go too much into it because we're not gonna construct this right now. I'm just showing you this so you can sort of see how this basis for a pattern is great and has all these different opportunities to it. And I get lost pretty easily on it. And so we demonstrated now silver rectangle, great character. It is a metallic mean, and also, well, one of the divine ones, the link to the octagon. Ain't that nice? Okay, so next step, next thing, you guys ready to move on? We're gonna move on. Now we're gonna do the heptagon. We're gonna fold a regular heptagon, and for this one, actually I have a file for you guys. I have a file you can download and you can look at it, and it's gonna be the instructions to the thing. And it's great because it's gonna help you in case you're not following along, you can just follow the instructions in the thing. But we are sort of gonna reinterpret the steps. So I just sent it to the chat, so be sure to check that out. This is by Tom Hall from his paper called Heptagon. So everybody open that up and just look at it. And notice, first thing first, first step requires a square. So if you don't have a square, I'm gonna make a square just in case you're with me, just in case you're like me and have a rectangular piece of paper. So I'm gonna make myself a square. The way I make a square, because I don't want the diagonal to be in the way, because the design has no diagonal. So I'm not gonna do the diagonal. I'm just gonna fold a little bit on the corner, making sure that everything is lined up just so I can have it sort of flat. So all this line is flat. With the line flat, just making sure that it's on the edge. Then I make sure that this is hitting on the bottom there. Da, 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 da. And so at that point, that's where I need to cut away. So I can just hold it at that point, sort of, not too tight, not too much, but just enough so I can find where it is. So see, I now find where it is like that. And bring it down like so. And this I'm gonna cut away. So this construction actually requires an alarming grade of precision. But I'm not saying that to intimidate you. I'm just saying that because, if you don't get it right the first time, don't worry about it. It took me a couple tries. Technically, I'm still trying. Last one I did required some moving around to get it just right, but it's there. Trust me, it's there. Okay, so first step, right? We have a square. And now the instructions say that we need to cut this vertically and horizontally. So I have my square.
Just hold off 1 second so we can catch up.
Yes, of course.
Thank you.
Yeah, you're welcome. In the meantime, I'm going to, where is the thing?
Did you put those instructions in the chat?
Yes, in the chat.
I can't see it.
No, they're a picture I sent in the chat.
I didn't. In the Zoom chat?
Yeah, in the Zoom chat, there's, I sent a picture there. I don't know if you can see it.
It's just a link that we can download.
Yeah, that's it.
What I'm saying. Okay.
Yeah, that's it. It's a picture you can download.
Okay.
Can anybody else link it again? I can't see. Oh. Okay, doesn't matter.
No, wait, can you see it or not? I can send it again.
Nope, I still can't see it.
I'm going to send it again.
Some of us can and some can't, it seems.
I sent it again.
Nope. Maybe it's just the connection with the iPad or something. Doesn't matter.
Okay, I'm going to share the screen. You can take a screenshot. How's that?
Oh, yeah, please. Camera.
That's the thing.
Okay, just 1 minute.
Mm-hmm.
Okay.
Okay. Now, just as a side note, we're going to skip or reinterpret steps 9 onward. We're not going to follow exactly. I don't like what he did there. I prefer some other methods, but that is too messy. Okay, I'm going to stop sharing the screen now. I'm going to come back. Oh, nice. Somebody linked the PDF. Oh, sir. Nice. Wait a minute. Where is my? I just had it. I just did it. Where's my silver spiral thing? How could I lose it? You see, this is the magic of video. You don't get to see the behind the scenes. It looks really tidy right in my little rectangle here, but no, you should see my desk. Well, I won't go too much into it, but okay. So first step, vertical and horizontal folds. Vertical, horizontal. And then it instructs us to do 2 folds at the same time. So it pretty much goes backwards. So you can either turn the paper over or just fold it backwards. I prefer to turn the paper over just to be sure that it's actually precise. So that's the top one, right? And now I'm going to do the left one. And there it is. So that's step 1, pretty much. Step 1 complete. Now should look like the one in the start of step 2. Now what it says is that we should find the midpoint between these 2 points, this line. So we pretty much take this point. She's calling A and B. We put B to A. And we just sort of a slight decrease. We just want a reference. And now here's what he's saying. We need to take, he's actually calling these points something. So we're going to take that point, but I'm marking a line just to indicate that it's the point that's on the line. So it's the combination of the edge and that intersection. So that's one, and that's the other one. So he's saying that this is P2. He's saying that over here, this is P1. And now he's saying that, well, we have L2, which is the whole line that's going down here, and L1. We're going to take P1 and put it on L1 and P2 and put it on L2. So it should look a little something like this. So I'm keeping an eye out for my fold, my crease. You should see it there a slightly bit. That's one point. And the other, I should then pivot it. So make sure that the fold has both points falling on their respective lines. Sort of helpful there to have the very corner of the thing. So up, 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 up. And then we fold down. And so that's step 3 complete.
Can you just open it back a couple of steps?
Yeah, sure thing.
So even before that, we just folded the top, the back, and the top and the back down. Yeah.
Pretty much.
Yeah. Okay.
I went first for the top, and then I went for the left, and then step 2 was finding this middle point, this point right here, this P2 thing. So it's pretty much just putting that onto that, boop, boop. But you don't fold it completely. You just fold slightly, just here. Taka, taka, taka.
Yeah. Okay.
Then you have that point, that's P2. We have over here, that's P1, which is the central division. And now we have that, this whole line right here. That's L1. And this line down here, that's L2. So that's L2. This is L1. And so what he wants it to do now is match P2 onto L2 while P1 is falling on L1. So that point falls on this line and the other point falls on the other line. And we just fold that. Up, up. So because we have an overlap, this should, to me, this always like comes out a little bit. But it doesn't matter because what we care about is the fold that's underneath. We want this one. So as long as these 2 points are doing their thing, that fold underneath should be doing its thing as well. Making sure that P1 is onto P2, that kind of thing. Good. And now he's saying, well, here where P1 matches L1, here, right there, that's where P1 and L1 match. Right there, we're going to draw L3. So L3 is a perpendicular at that point. So we saw how to draw perpendiculars a little bit. So we have a point and we have the edges of our shape. So at that point, we're going to just pretty much just turn the paper over, right? Just be clear. That point is P1 right there. I'm going to turn my paper over. I'm going to lift the whole thing up. I'm going to match it to my edge. And while I'm matching it, I'm just going to make sure that right here, when I press down, it's falling right on P1. Right where P1 is matching, that's where I want it. And that this edge also is. So I have to complete those 2 things. So this edge is falling on itself, and here it's falling on P1. See, right now I'm looking at it and it's a little off. So it's a little more, that one's what I was always missing. Like that, this line is crucial. If it's off by a little bit, the whole heptagon construction will be a little bit off. That's annoying, especially when you're thinking like, oh, this is so much effort. Why can't you be right? So just making sure that when I turn it over, it's exactly as I can make it falling on where this line is hitting. Da, 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 da. And now we're step 4. This is step 4 complete. Now step 5 pretty much is saying several things, but it's first thing saying unfold. So now we have L3. We have a new point he's calling. Well, he's now naming several points. He's naming the center as O, and he's naming where this line hits the edge as C. And he's saying, all right, now we're going to take C and we're going to put it onto L3 right? And the fold is going to go through the origin. So the fold needs to go through the origin and make C fall onto L3. So it's going to be L3. So C has to fall onto L3 while going through 0. So we're going to lift it up. We're going to see that it's O. So I can sort of see the intersection of these two lines, these two vertical and horizontal. Once I'm there, I can sort of just pivot it. Make sure that C falls on L3. I can open it up just to be sure. Doesn't hurt. Something I like to do as well is making sure that these folds are mountains or anything that's opposite of what I'm folding. So if I'm folding a valley, then I make the folds mountains, and that's going to help me sort of see if I'm right or wrong. Because if I'm right, then that line or that fold I'm doing should interact very nicely with the other fold. So I can see that I'm a little bit off. I'm a little bit off. A little lower. That looks right.
So we're just lining up C to P3 to L3, right?
That's correct.
Okay, going through O.
That's correct. Exactly right. And now he's saying, well, all right, you got your C on your L3, right on. But now we want to draw a perpendicular on this new fold and at C. So, taking into account what we've just learned, he's also saying it to do it in valley. So at that point, we're going to take this remaining space and we're going to fold it and make sure that the fold falls on itself. So this is falling on itself. I take it, put it down like so. It falls on itself. It actually, I think, falls on L3. It looks like it is. I don't know why he wouldn't say if it does, but it seems to fall on some intersection there. It might be wrong. It might not be. It might be slightly separated there, but
Do the back line up in this case? We're making it perpendicular.
I don't even do that step. I mean, from there you can bounce it around.
yeah, that's
Once
true.
you have that line, I don't really follow him after that step.
That's a good idea. So I guess we're not changing this pace at 8. We're changing the pace at 7, it seems, because we have what we needed. We really do. We have what we needed. This line was all we needed. That was the whole
Can
thing.
you just repeat that last bit?
This line that I did?
Yeah, that one I didn't get.
Yeah, I think we can skip it though.
Okay.
Because pretty much what that's doing is just solidifying where C matches the L3. But what we can do as well is fold the C onto the L3 like so. Yeah. So the fold that goes from O
C,
matches C to
yeah.
L3, that one, pop.
Yeah.
And then what you do is you pretty much make a fold that makes the other side fall on this fold like so. You see what I did?
Yeah.
Can you just go back one step? How you
Yes.
did this one?
So we have
Okay. Yes.
we have the C and we put it onto L3. And then what I did was I sort of this line that extended after O, which is the same, this line that goes through there. And then I just, it changes into a mountain. And what we're doing is pretty much copying this segment onto the other side like so.
It's not matching up here. So.
Mm-hmm.
Okay, so once we have this, now it's time for the spins. See if we did it correctly. So now we have this hinge. Wait. getting focused.
Oh, it's gone all fuzzy.
Yeah. This autofocus thing. Come on.
Yep.
Mm-hmm. Okay. So you have this hinge. You're gonna take that hinge and just put it down next to it. It should hit O, of course, and then you can turn it over and you do the same thing to that side. And now you can sort of lay it down on this.
I'm still stuck at trying to match C to...
To L3?
Yes.
Yeah, it's a doozy. That's actually the key. So this one, right? So it goes to the center. So that for that trick, what you can do is sort of make sure that it's interchanged. So that means that the fold is opposite of the lines that intersect with it. So for me, it's the vertical and the horizontal.
Okay.
So I have those in mountain. And then the fold that I'm going to do there goes as valley, so that when it goes through, it's going to interact with those mountains. So it's going to look like this now.
Okay.
So that's a way of making sure that it goes. And then once it's lined up to L3, what we want is a fold that copies it. So a fold that pretty much, that segment after the fold then also copies the other way. So once it's matched, like you do the whole fold, right? You do the whole fold and then you unfold and then I click it, like make it go back a little bit, and then I can fold that onto L3. And so this fold right here, that's what's remaining. And it becomes a mountain. And then everything else just falls into place after that. Like the whole back thing is going to fall right onto it. But then, it disappears. So it's folding behind. So 1, and then 2. And so what we want now is pretty much just to keep copying this angle. So to keep copying this angle, we have it like this. So I had it. So I did the hinges one way, and then I unfold and did the hinge the other way in order for this to be sort of free. Now I can lay flat and everything else could be just flapping in the wind. So now what I want is to fold in such a way that it keeps falling on that line. So on those lines that I folded, I want the rest to keep falling on it as well. Just for everything to match up. So I'm doing sort of the same thing with the hinges. Whenever I see one of these pockets, I open it up. And then I line up to the edge and I fold. And when I hinge the other way, I just want to make sure that it falls exactly in the middle line. So when it does this, it's actually happening on the middle. Same thing, I open up. And so you see, I made a mistake. Somewhere along this fold, somewhere, this is off. Everything should match. If we did it correctly, everything should match. Like it should be a perfect heptagon. So it should be, yeah, somebody did it right. But it was not me. So let's see. I'm gonna have to do it again. Put this to the side. And see, the construction is correct. Like the idea is totally correct. Now it's just about the execution. But because one mistake compounds, so you do one mistake and the sort of like goes on to the next and goes on to the next. And every time it sort of piles on, it becomes worse, or it becomes more imprecise. It just gets, yeah, it piles up and piles up. And so one little mistake cost me the game there. Just like chess. So in case you're wondering how I used to do the heptagons, I used to do them by getting an octagon and folding away the slice of it. And that would give me 7 slices. But it was also like a little dome, a little cupola. And then I'll put those 7 points on a piece of paper, and that'd be it. It would be imprecise, sort of like the imprecision I just committed, but it was just the way I did. So I tried to figure out once how to do the proper division that I wanted. I didn't know much about mathematics then. I was just going on hunches. And one time I actually, like while I was trying, I think I was on a train, and I got it. Like for some reason, just messing around with it, I got it. Like I got exactly a heptagon, but there was no rhyme or reason. There was no science behind it. There was no sense to what I did. It just worked because I got lucky. But that was it. It was just luck. There was no, I don't know how to explain it, but it was completely luck. I got excited. I thought I cracked it, and I did it again. Of course, I was wrong. I actually made a mistake, but that mistake made my initial error sort of correct, if that makes sense. But anyway, I kept looking for a heptagon design, didn't find any, and then out of nowhere, this year, a couple days ago, actually, I found that paper, that heptagon paper by Tom Hall. And, you know, the math looked complicated, so I guess like, yeah, it looks legit. And he had these instructions to it. And I tried these instructions that we're doing now, and I didn't get it. Like right now, like it was a little off. I'm thinking like, they scammed me. Nobody's doing these things, and this people can just print whatever. What's the world coming to? But no, I was wrong. It was me who made the mistake. It was not the world. It was not Tom Hall, but I. So I did it a couple times. I did it 3 times, and then, yeah, Sarah was doing the Islamic Patterns in another class, and in one class she was like, she said she was bored or something like that. She was not properly entertained, and so therefore she was not demanding, but she suggested that we try the heptagons, because that is challenging, because you don't usually see that with compass and straight edge. The reason being, you can't construct a regular heptagon using compass and straight edge. You're always approximating. You're always guessing. So there's a lot of designs out there, like in the Islamic world, that have 7s. And I guess they must have found a way to construct them. I mean, there are practical methods. You could just get like a hinge, you know, you can just get something that's one, you know, length and just put it together to 6 others and just be unconnected, and boom, you got a heptagon. Like it's not, you know, you're not bound to construction by compass and straight edge. I think they weren't either. Like, I don't know, like back then, right? But anyway, yeah, so there are some patterns out there that are not sort of accessible through traditional methods of construction, which this is what I'm calling compass and straight edge. And yeah, so she had this pattern, this 14-fold pattern that she wanted to try. And I have this heptagon method that I couldn't get it, and I you know, just the stars aligned and it worked. I just got it right. I don't know what it was, but it just got it right. So okay, so that's the magic thing. So I put my C onto L3. So now that's the money maker. Now it's about putting it on the right sort of sequence on it. And so I don't know, there was this pattern once that I also did, but I did that on the computer, but you know, it was, I did it on AutoCAD. And the reason why I use AutoCAD is because it has a function there for mirroring, which is great because mirroring is pretty much like the basis of folding. Like when you fold a thing, you're pretty much mirroring on that fold the remnants of space. So that is to say, like if I am constructing this thing and I have this on AutoCAD for some reason, and I'm just curious because you actually draw the fold before, and I'm go like, all right, I want to fold there, which would then make it sound like I'm some stuck-up kid or something. I want to fold there. So you do your fold there. I'm gonna have this tool. But wait, where's my ruler? Whatever. So I put that fold in there. Oh my god! Wow. And then if you do that sort of mirror command on that line, then that everything else just falls over. Like that's a mirror. You know, all this space after it mirrors on the fold. So that is why I prefer to use AutoCAD. So using sort of like the 14 as my base and that design, which was a sort of one of those what are the names of those things? I love those. It's those that are like carved on rock, but they're like these vines, so like the sun can go through. Like they use them for windowsills, like not windowsills, but like the window, like they go on windows, but they're made of like carved stone or wood, and they're made for light to go into the room. And yeah, so it was that design, but it was a 14 fold. And by using mirrors, everything just clicked, everything connected real nice. And I sent that to Richard actually. But I always wanted to, I've always wanted to fold it, and I still haven't. So, you know, this might be the day. This might be the day. After class, I just might, I don't know, maybe during class. No. I'm not going to do something in class I haven't done before. Or that's what I'm going to tell you. But let's see if this time I get it. So where's my C here? It doesn't matter, just have to keep that going. So I'm going for a more clean approach. So I'm just actually making sure that everything's sort of lined up. And another thing I can do is once I have a couple of these, I can just extend them. So for instance, this line that I have is not extended, but I can extend it if I wish. Just making sure that it's actually lined up, and then boop. And this one isn't either. So because it's a regular polygon, because it's an odd number polygon, the radiuses will become apothems, and the apothems radiuses, radii. Whereas in the even-sided polygons, there is, what's cool about doing what I'm doing right now is also you can sort of like match them. The lines should match because it's a regular polygon. So for instance, there it's not matching. Here, that should also match. What was I saying? Oh yeah, even go radius to radius, apothem to apothem. But our numbers have little, they're tricky. They're tricky like that. A way that I sort of resolve when I'm looking at a pattern and try to guess, or not guess, you know, try to determine what family it belongs to. And by family, I mean the symmetry, the fold of it, as they call it. It's interesting now that they use the word fold in English to describe the pattern, but nobody thought to fold the thing. That's what's weird to me. Like, nah, they knew, dude. Like, come on. They call it fold. Come on. Of course they knew. Anyway. It's that odd number polygons have a head and 2 feet. And then all the arms. So you can sort of like take away 3 from any odd number, and then that's how many arms it has. Like a pentagon. Think of a pentagon. So if you have a pentagon and you sort of lay it on the ground with the feet at the ground, it has a head and 2 arms. And the heptagon has 2 feet, a head, and 4 arms. Remind you of anybody with 4 arms? I forget the name, but there's a god that has 4 arms. I can't remember. but it probably, you know, has to do with the 7. And 7 has a very, oh, I got it right this time. Praise Jesus. No, well, not Jesus. Praise God. Praise God. It's my Christian upbringing. It's hard to sort of like go against your programming, but you can do it. If I can do it, you can too. It's a noble aspiration to reprogram oneself. Okay, so once, let's say you got it right, because you know God smiled on you. So now what you need to do is find the line that's gonna help you cut away. But because the center of the heptagon is at the center, that's sort of inconvenient for us a little bit, because the feet are not going to match up to, so it's going to be hanging some way. So either we put the feet on or we put the head on. So we have to put the head on because the feet are going to be hanging. That's what it makes sense to me in my head, but it sounds like nonsense. But it pretty much goes, we find a point that are these two. So let's say that this is my L3 and this is my C right here. So I'm going to draw a line that goes, so as you can see, between C and the next point. So I'm going to count them out. So I go, probably going to, well, whatever. Damn. Okay. I'm going to count them out. So every mountain I'm going to count. So this is 1 between 2 mountains. That's 1 slice. 2 slice. 3. 4. 5. Oh, that's very messy. 6 and 7. That's pretty much the thing, right? So now what I want to do is I'm going to take this line that goes, you know, that's between this slice. I'm going to make sure that this is my C. It could be the other way, really doesn't matter, but I'm going to use, you know, relative to the construction on the instructions. I'm going to lift this line up. I'm going to make sure that this fold starts at C, and then you're going to make sure that this fold falls on itself. So I'm going to draw a line on the fold, but on the other side, so you can see well. So this fold falls on itself. See that? So it continues, and then you fold that. Now, because we're in a folding class, we got to fold what we want to cut away. But if we, you know, if we had some tools about us, we could just have this folded and then return to our original sort of construction, like this thing. And then just sort of find where this line is. So it has to be on the other way. So there's my line. So if I cut away at that line with an X-Acto knife or some scissors, it would give me my heptagon. But since I'm supposing that, you know, I only have my hands and no tools, I have to actually fold all these down. So I have 1 down. And then, well, there's several tricks that I can do, but I can sort of also, the trick I've been trying is I find where that hits, right? So that's hitting. So at that point, I have to, again, make sure that when I fold down, it falls on, this line continues. So I have that point where they intersect and the line continues. And so it seems one of the arms is touching. So it actually will end there. So 1, 2, buckle my shoe, and then 3, 4. That's an Elvis song, isn't it? 1, 2, buckle my shoe. 3, 4, get out on the floor. 5, 6, come get
Way
your
older
kicks.
than Elvis. That's like a child's nursery rhyme.
Is it? No, I'm sure Elvis did something with it. I don't know. I remember in Pulp Fiction. They have that song when they go into Jack Rabbit Slims. So yeah, anyway. Now this one's easy because it's at the very corner. So the other one's going to be the same. And see, what's cool about what we've done is that we've done something that is impossible to do, like literally impossible to do with a straight edge and a compass. And so the world of possibilities is, you know, in front of us. A whole world has been previously untainted, undiscovered. So now with those two unfolded, I can just sort of find where that intersects my point. So that's why I'm turning it over. I'm turning over just to see that it's actually hitting at the corner I want it to hit at. And then that's my heptagon. Now I know we jumped to some deep waters right here. You know, we went to something a little bit more complicated. We did something that's, as I said over and over again, it's impossible to do with a compass and a straight edge. So it has its trick, but at the same time, it's just 10 easy steps, right? But, you know, congratulations, you guys. You know, you're one of the few people in the world that does this, that has this thing in your hands. Like an exact heptagon, a constructed heptagon, like you did it. You made it come into being. The heptagon has very interesting properties. Like, I don't know how to explain this, but like, this is the most mystical shape that I know. It's the one that keeps calling to me. It's been calling to me since I was a kid. And it's something like, it's very, I don't know how to say it, like seductive. But I find it, I don't know, I find it all around. Man. You think it's funny, but I don't know. I think it's funny. But I guess like what's cool about like numbers meaning things is that you can't find what it means to you in a book. No matter what the book is about or what symbols from the old world they're sort of referring to, what it means to you can only mean to you. Like there's no book out there that has the meaning. Like as much as they go like, oh yes, in ancient times the 7 was used for I don't know what. That's a clue. You know, that might help you to understand a little bit more about the history of the thing. But what it means to you, that's happening. Like that's real. That's now. It's like dreams. You know, like you can't find what a symbol of a dream is in a book. You cannot. The meaning of that dream is only, you know, sensible to your unconscious. And it's the same with numbers and figures and shapes. And they have that possibility of meaning things. And you know, there's the archetypes, of course. Like that's what it's worth to read about, like the archetypes. So, for instance, a great book to read about an archetype is The Hidden Geometry of Flowers by Keith Critchlow, who is, you know, some of you also follow Adam and Richard on the Art of Islamic Pattern. That was their teacher, Keith Critchlow, and he was an architect. He died this year. I don't know what he died of, but he died this year. And yeah, he has this book called The Hidden Geometry of Flowers. It's an amazing book. I love it. It's huge. And it's funny because I remember when I wanted to read it, I Googled it and like without me wanting to, it was just like the first thing was a PDF of a draft that was sort of like leaked onto the internet. I'm like, should I click it? And of course I did. And so that's how I got into it. And then I just started reading about it. And there's all these beautiful constructions there about overlaid geometrical, you know, sort of these lines and circles drawn over flowers. and how they matched. And, you know, reading more on flowers and things like that and talking to people. Somebody told me once, like, I don't even know, like, I have a source amnesia on this. By the way, source amnesia is a phenomenon in which, like, they will throw a headline at you and you sort of like register that headline or that phrase. And then, you know, you go about your life and then somebody mentions that thing and you're like, oh yeah, isn't that the guy? And you just sort of like, you know, repeat the headline or the phrase you read, but you don't even know where you got it from. So I got that from this phrase that somebody told me that all the fruits that people eat have five-fold flowers. Not all of them, but like if a fruit comes from a five-petal flower, it's probably edible. I don't know. He listed a bunch of examples: apples and strawberries and limes. Everybody got their heptagon?
Not yet.
No. Yeah. Oh, nice. Like this. I see somebody there got it. Nice. Surabi got it. Right on. So one of the things I like to do whenever I got a new figure in my hands is, well, trying to get the stars in, right? So what are the stars? So just in case you're new, I'm going to tell you. But I go over this every time I can. Like, it's one of those things I've always been repeating, sort of iterating out. So I'm going to use the Schlafly symbols. So the Schlafly symbols are open brackets. They have, well, the brackets rather. Oh my goodness, that is the worst bracket I've drawn ever. Doesn't get any better. All right, so we have n, that's the number of sides the polygon has, and then we go /k, and we close brackets. All right, so what's n? N is the number of sides. Does not equal 2 points. And k is what's going to shape our star. So shape is another, k is another number, and k has to be more than 1, and k has to be less than half of how many sides it has. So that's the rule for k. It needs to be less than half, more than 1. So if we just plug in different numbers, we'll find that we can't get a star until 5. Right? So if we put one, I mean, first off, the first n is 3. There's no n, there's no shape that has 2. Like that's a 2. A line. So the 3 is it's 3 points. So that's the first polygon, right? That's the 3. So then that's the first one. So we plug in 3. Well, we can't, yeah, there's no number that's higher than 1 and half and less than the half of 3, right? It would just be 1.5. And that would be itself. I don't know. It would be nothing. That's actually interesting. And then we have 4. And so that goes, yeah, let's plug it in. So half, more than 1, half than 2, less than 2, more than 1. Again, nothing. Then we get to 5. And this is what I mean with the feet. So this is like the head and the arms, and the feet is touching the floor. And for that one, we do have a star. We have 2. So then the k number for this one would be 2. So 5, 2. That looks like 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. That's a 5, 2, the pentagram. That's the first one. So next star that happens is a 6, 2. And the 6, 2 is the first compound star because 6 and 2 have a common denominator of 2. So they can be simplified into 3, right? But the way we write it when we simplify in the star terms is that we take this number and we put it out and we leave the result inside. So this one could also be written as 2, 3. Because we're not looking for a sort of a simplification. We're looking for, we want it to be equal. We want this, like if we were to multiply 2 and 3, we'd still get 6, right? We'd still have to sort of like say that this is a 6. So that's the way we could write it. And that looks like this. So it's a compound. It's 2 3s. There's 2 triangles. 1 triangle, 2 triangle. So we got the first star polygon, the first compound star, and then the 7 comes in with the first double star. So it's the first figure which has 2 stars inside. because there's two numbers that can be less than half of it. So half of 7 is 3.5. So it has 3 and 2. Right? So that's the 7, 3 and the 7, 2. That would look like 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. That's the 7, 2. And well, we could actually draw the next one inside, or there's another trick. When you extend the star, you get to the next one. So if we have, all right, how do we explain this? Okay, so all the stars have all the other stars within, like of that family. So you can see that inside of the 7, 2 is a 7. So at these points, there's a heptagon. And if we just extend the lines of it, we find that we get to where it hits for the 7, 2, the first points I drew in. So if I keep extending these points, they actually will sort of find another match. They're still a little inclined, so they sort of like will find another point. And that'll be the 7, 3, right? It'll go 0, 1, 2, 3. That's the line. And so it'll keep going. So all the stars sort of have the other stars within. Then 8 also has 2 stars, but the 7 is the first one that has 2 stars. So now, when I get a figure like these, I try to find my stars inside. So for instance, I go 0, 1, 2. And here's a cool trick where you can get like instant gratification. You fold the star on the radii in one way, and then you turn the paper over and you fold the same star, but on the apothem. You fold it, so instead of going for, that's your origin point. So instead of going 0, 1, 2, you go 0, 1, 2. You draw that, but on the other side. So I'm going to keep this going and leave it folded as I fold them. Because you never know, like some shapes can also pop out at you through negative space. If you do this sort of like with the 10-3, so if you have a decagon and you do this with the 10-3, you will actually find some of the girich, I think that's how you pronounce girich, shapes. No, sirich. This is with a G or a C. But those 10-fold shapes, you know, like the bow tie and the ribbon and the fat little star of the pentagon and whatnot. So now for me to go to the next one, I have to unfold this. Go on to the next one. On to the next one, and so on and so on. By the way, we have a Discord channel, which at the end of the video, I will give you a link to it. So be sure to stick around for that. That Discord is where people are posting the things they fold. People are sharing music, surprisingly, and academic papers and origami instructions. And it's cool. It's free. And you also get access to the links for the class, so you don't have to wait for me to send you the links. I'm going to, that's where I share them. And I'm trying to keep a constancy on the class times, but I haven't missed the English classes. The Spanish classes, those are the ones that I've been moving around. And yeah, now there's a bunch of stuff there to be uncovered. I mean, with the heptagon, I'm back to talking about the heptagon. So now I have my 7-2 star right there. There's always like these things that you can do to it, just to have fun with it. Sort of like to get it to express itself. The platform is a Discord. There's a link there. Sarah shared as the invitation to it. You can click on it, and you get right to the forum. So it's like a private forum, and it's great. It's a great place for resources, and people are sharing stuff and whatnot. So my hope is that I'm going to teach you how to fold these shapes, and somehow it's going to ignite your imagination, and like a whole world of possibilities is going to open up before you that wasn't before. And with that, it just might make you a better person. It just might. Okay, so what now? So, okay, we got the 7-2, so we can do the 7-3. Or we can do the nest. Or we could do the same star, but on the apothems. I like that. So let's do the apothem now. So I got the 7-2 on the radii, so at the corners, and now I'm going to do this one to here. But see, that's what's cool about these sort of designs, that there's always something that you can do because there's many different relationships. There are interactions, and they are not always obvious. So they do need some exploration. They need some play. And when you get to folding origami for a long time, you get to see that a lot of it, like at least the animal designs, a lot of it is trial and error. Like there's some dude out there that is playing around with this piece of paper, you know, just going about it.
Which of these folds are you doing now?
I'm doing the 7-2, but on the apothem. So that means that at the fold I'm doing, I'm making sure that it falls on the midpoint and the midpoint. It's 7-2 again, so it goes 0, 1, 2. So
and
I can
you
actually
fold them the opposite direction to the previous ones?
Exactly right. Exactly right.
Turn it over and then do it.
Because then it has these relationships to it. So for instance, we see that it actually crosses right there. You see that how?
Oh yeah.
So that's an interesting like subject of study, because it's true, like it's real how there's actually this deep and profound interaction between stars on the apothem and stars on the radii, and a lot of Islamic designs actually use these interacting stars, like some at the apothem, some at the radii, and there's no rules. There's just the fact that they interact differently. And so as a designer of patterns, what you get to do is sort of choose where and which of the stars you want to take advantage of, if you will, or rather use for your own motives. So when I fold, I'm just also making sure that it intersects, that it hits there. So here's another trick that you can do to draw the stars. So, all right, I'm gonna select my target. So my target is gonna be here. So that's 0, 1, 2. So what I can do is sort of help myself by, you know, folding everything that's not.
Can you just wait 1 second until we've just folded all those?
Oh yeah, of course. Oh yeah, I'm just like going over tricks because it's the same thing.
Okay,
There's another way of doing the same thing. See, I'm almost done, but now I'm missing just that one. So if I wanted to do like, you know, wanted to be exact and precise, I could just fold away everything that's not that, you know, I could select it. And so now that's easier because then I could just lift my paper up and just make sure that it falls on the corners there, see? Now, a lot of the Islamic pattern designs, they tend to use or like need sort of double of whatever you're working with. So if you're working with 6s, you need 12, or rather you need to find a playful way of playing around with the 6s. I know of one for the heptagon, but it requires a square. So I haven't done it yet, but I think that this construction might help to crack it. But that's pending. We'll see how that goes. But I think that's going to be a likely crack soon. But in the meantime, you know, we got these guys. So they sort of want to do something. That's when we're looking at it. Or we could now have this small heptagon and then inside of it draw the other star, so another star. We can also see that we have a rhombus here. You know, if we fold this onto it, we find that they're the same, so we actually have a rhombus. So, you know, for me personally, I'm inclined to then find the rhombus that goes here. So almost to copy this angle and find where it's on down there. just one. That's just me. But another thing that we can do is put the 7-2 here. I think that that would be ideal. 7-2 here. Well, also, that's another thing that I'm thinking about. We could use these sort of shapes that are coming out as the polygons in contact technique. So we can also sort of like draw these things inside of it. And then, so for instance, if we have a heptagon here, we have this shape, and then we know that it goes out. We just need to put in an angle of incidence in which it goes out, and then we sort of like bounce it off of this shape, and then it'll go about the other way. So it's like an easy way of getting an Islamic pattern. We have a central polygon, we have then this outer polygon on the outskirts of it, and then we have like whatever. But if we have an angle of incidence on it, we can then sort of use it as a pattern. So let's try to put in the 7-2 at here. Well, we have the option, right? What do you want to do? You want to go about here, make it smaller? Or we want to just like, no, we'll stick to this scale. Let's find the pattern here. See, so many options, so many options. Personally, I want to be ambitious and just keep on going. But also I want to sort of move on to the next before we run out of time. So let's do the 7-2. Let's do the 7-2 at the apothem right there. Oh, you know what we can do? We can do both. Yeah, let's do both. I like that. So we're going to sort of repeat what we've done, but now inside of this other heptagon, the one inside of it. So again, 7-2 at all these points. So they go 0. And also try to retain. So if it's at the radius, try to make it so it's at the radius, like the same sort of fold. So if this fold that's at the radius is a mountain, then this fold right here will also be a mountain. See? Oh, and again, we're just at the tip of the iceberg. Like if we folded the 7-3 at the same points, like there's a very cool relationship that comes out. But this is so new to me. Like at least like having a regular heptagon in my hands, this is new. Whenever I did it, I used to sort of construct them from an approximation and sort of fiddle around with it, but never like this. So also I'm looking out here for the intersections on my side of the paper. So conveniently I have them marked with points on the other side, of course, but if I miss, I just push my paper forward a little bit and then refold. That's no trouble. It's better to get right, and the paper will prefer to be right than wrong. So even if you have a wrong fold, if you then correct it and just make sure that it goes to the intersection, the paper will prefer to do that because it'll be less resistance. If you miss, it's more work for the paper to sort of go to it. But when you correct it, the paper will be like, oh, thanks. That was making me tired. I guess it's in human nature to sort of anthropomorphize everything. So I anthropomorphize paper all the time. I say that it's talking to me. But what I mean by that is just that, it'll allow for certain things and will forbid certain things. Or it will prefer to do things. So, it suggests. But the 7 is so weird in its symmetry that, you can't fall for it. You can't just, yeah.
I have to leave now. Will it be possible to get a recording of the rest of the video?
Yes, of course. Send me a message through Instagram. Just remind me. As soon as the class ends, I upload it to YouTube.
Okay, thank you.
Although that I have it unlisted, so I have to send you the link.
Okay,
So just remind me.
Thank you.
No, thank you for joining, and I'll see you around next time.
Okay, have a wonderful weekend.
Yeah, you too. Thank you. Okay, so that's inside now. So I have my 7-2 and my 7-2 inside of my 7-2 and 7-2. And, you know, something's happening. You know, by itself, there's a lot of things happening. See, for instance, now I can sort of play around with just the way that it is. I have these things there. I also have these sort of coming out here, which I can take advantage of and sort of get a spin on it, like so. But the cool is that then they sort of combine to the next one, so I can actually, you know, properly. Let's try one at a time. So 1, 2. So this is usually how you make a crown, what I call a crown. The idea is sort of like a very cylindrical design, and then it'll sort of collapse like so. You can always go in further, and you know, the further you go, the deeper, the higher it gets, like the taller it gets, rather. Like a little bowl of it. And then usually, well, that's what happens with the pentagon. Well, what happens with the pentagon is that you can sort of like use these folds right here to sort of like get it to tighten and, you know, stay there, stay put. But I don't know about this one. Let's see, another thing that's jumping out at me are these rhombi. These rhombi now have this intersection there. So I'm inclined to just fold between and fold it both ways. And then you just sort of take advantage of it, like so. And that would be a lock. So locks need to be at the corners. We haven't very much touched on the lock idea, but it's something that kept me up at night when I was a kid. A lot. I would just do that forever. And in class, it was just about making these locks in other shapes, of course, but essentially works the same. It's pretty much having nested, nested figures inside of these figures at the edges, and sort of like using those to sort of sacrifice space and have it be held together. They can always be a clickable thing. Always fun. So what I was talking about with making the patterns of the apothem so that you can find no relationship. Let's just see how it looks. So I have this one at the apothem, and that goes blah, 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 blah. And then, but what I'm going to do now is I'm going to stop at the line of like at this line. So I have these lines there, like lines of symmetry almost. And so what I can do, like to keep it, you know, Islamic, is have them bounce off at that point. So when they hit this line of incidence, I can then sort of use a mirror there and sort of bounce it off. So it has to be, it's this one. Which one is it? It's the one that goes to the corner. Okay, corner. It's a little less, so it's actually gonna pull on it the other way. So that's interesting. Apparently that line hits right to the top there. So it's like a corner to apothem line. So up all the way down. So because we want it to exit also. So it's not just a matter of bouncing, but a matter of coming out. So it needs to come out either. Yeah, it needs to come out through there. So apparently it's coming out through 2 points. So well, if then I mirror this, then it will also come through there like so. I don't know. It's weird. It's always weird with the heptagon. I guess also what we could do, instead of bouncing it, we could just draw a fold that goes from here to that other point and then just keep going at that angle, but that angle is nothing. And so we don't want nothing, we want something. So the search continues. I'm just going to draw in this heptagram. And then when I draw in this line, well, I'm going to do a little final thing. I'm going to just sort of solidify it, make it final. And then we're going to move on to the next exercise because time. But now you know how to make a heptagon. You can always watch the recording and whatnot. Yeah, world of possibilities. See, what's coming out of me is like, for instance, this. So that's something that's coming out of me. Then what else is coming out? We have the spiral that we looked at, sort of like the bowl of the thing. So that was fun. That was good. You could also accentuate around that. Okay, we have this, which is neat. So like this rum. It's also another way of sort of like holding it down. It uses some lines there at the bottom. We already have those. That's good. This division apparently also retains the sevenfoldness, apparently, but I think not really. See, that's the thing about the sevenfold. It's so strange. It is so strange. It's not like any of the other figures. So sometimes the clues that we have on the others will help us, but it's very weird. Like it's not exactly 6 and it's not exactly 8. You know, it's just between those worlds. I don't know how to explain it, but it's just very strange. But that strangeness is very enticing. Like it's just very demanding. It calls to you. It beckons you. You gotta go deeper. It just says like, yeah, you know, come on down. I got what you need. See, this is the anthropomorphization again. Now, if I were so inclined, I would just keep this going. Like I would just find more lines to fold into it and just go deeper and deeper and deeper. And eventually some of those lines will help me make sense of it. Then it would just be a matter of sort of having these collapse or fall one way or fall another. So for instance, one could also fold around this heptagon and then fold down. Bring this one down, but then fold back. It's 1, 2. 1, 2. 1, 2 back. One of the first posts I did on Instagram was a heptagon. It was a heptagon design. It's just like it's a star that I did this thing to it. Just folded I don't know which star, and then it was a beautiful like little locket looking thing. And now that I have the heptagon with me, I'm inclined to sort of go back and see what worked, what didn't, try to find something new. Twist times and tessellations, huh? So I guess a lot of the purpose of folding these sorts of shapes and having this sort of fun is to relax and sort of unwind and sort of, you know, let your mind at ease, because life can be very uneasy. But the truth is, like, there is this big ultimate truth that we sort of forget, you know, like there's this that nobody can express in a satisfying way, at least not normal people. I know I can't express it in a satisfying way, but it's pretty much like reduces to believing and hearing that everything is going to be okay. That kind of like idea, very basic, very big thing. Like, you know, it's everything's cool. The force of human nature is love. Like everything just works on love, and you know, you're cool, you're all right. Just be one with God, and everything will be what it's supposed to and whatnot. It's pretty cool. It's very profound. It's very true, and it's easy to forget, especially when you're working with things that are so trivial and nonsensical. You know, like money and time, things that don't really exist, really, and that take you away from the truth. But when you do these things, you sort of like, you know, you're not doing anything, you're working with your hands, and thoughts may come to your head about, you know, the things you like, don't like, what happened, didn't happen. But you, I don't know, at least for me, like it all fades away a little bit more. Like I don't feel as much and I'm folding. And I like that. I prefer that 1,000 times better than most sensations. But yeah, no, I got to put this down. I got to put this heptagon down because it's going crazy. So yeah, it's too much time now. We got to do something else. All right, so we're going to move on to, what did I say we're going to do? Oh yeah, the hexagonal games. So I'm going to take out another piece of paper. It's another rectangular piece of paper. So yeah, I hope that this heptagon at least showed you something about the ideas behind maybe exploring it. Because this whole thing, like this whole deal about this, do you see how it calls to me? No. Hold on. Okay, so we start with another rectangular piece of paper. You fold it in half like so. I unfold and turn it over. And then I'm going to fold one corner to the inside of it. So every class, I've been trying to show you some modulars so you can try out for yourself and sort of play around with them. And today is going to be no different. I'm going to show you how to do some modulars, but also I'm going to show you how to do this corrugation. It's going to be two things. Oh, but wait, we still need to do the Islamic pattern. There's one that I actually wanted to teach you guys. So I'm going to do this quickly. I'm just going to show you the unit. We still got about 45 minutes, so we're good. Okay, so we folded this down to the half, and then I'm going to turn it over. I'm going to fold the remaining edge onto the folded edge like so. Once that's folded, now at this point where it hits, I'm going to install a perpendicular. So I lift my paper up and make sure that it lines up with the corner there. I hit it, it comes down. Just make sure that the edge matches with the edge. See, I'm getting rusty because I missed. Then we're just going to rip this one out. Now, in order to get, a friend told me that that 2 birds with 1 stone thing don't work, don't fly. Because, you know, who wants to kill a bird, really? You know, I like that expression of like doing 2 things with 1 stroke. You know, just 1 thing you do and it provokes 2 things that are good. But killing a bird is not good, right? So, yeah, at a lack of a better phrase, right? But I'm not going to repeat it too much. But I'm going to fold this in half. So once we have this, we have a rectangle which has a height of √3/2 and a unit length here of a long length will be of 1. So 1 √3/2. We're going to fold this in half. And we're going to cut it away. So we're going to use one for our corrugation. We're going to use the other to make our modular. First one we're going to do is the modular. So I'm going to teach you how to do this. So now this half, we can also cut it in half. It's a pretty easy design, so that's what we're going to do it first. The other one, it's easy as well, but it requires a little more time and effort to try to get it to a point of satisfaction. So you have a rectangle. And now you're going to fold this in half. You're going to fold the short edge. There's a short and a long. You're going to fold the short onto itself in half, like so. Now you're going to open it. You're going to fold that onto itself. This design is by Francis Au, and I found this design in a Tomoko Fuse book called Kaleidoscopic Origami. I think it's a wonderful design. I think Francis Au really has some great. I say his name and I always think like of an owl, like as though this dude looked like an owl. I don't know why. So you gotta choose a side. So that means, okay, so I'm gonna go descend upper right. That's what I'm gonna do. Upper right, it's gonna come down. So I'm gonna take the whole upper right. So that's my upper right. Upper right, upper right. And it's gonna come down onto that center line like so. And then turn it over. And again, upper right. So I rotated. And now same thing, upper right, gonna come down. So it doesn't matter which you do, as long as when you do another piece, you sort of respect this. So there you go, you folded that down. Pretty neat, pretty cool. You unfold, you open, and then you change around the circuit. So by that I mean that if we analyze it, we have a valley, and then a mountain, and a valley. And so what we want to do is we want to change this one into a mountain and this one into a valley. So it goes up and then sort of on its own. It needs to come down. Same on the other side. So the pieces are still in the same ratio. So this rectangle is the same ratio as the big rectangle. You know, this rectangle could actually be used you know, in the same manner that the root 2 is used, and that you fold it in half, like into quarters, and you get the same ratio again. Except it's a little fatter, so maybe it's not that great for printing, but it could be a thing, you know. This is half of it. The half of it is pretty neat, though. The half of it goes like it's half of an equilateral triangle. So this is pretty neat. I think this is pretty cool. And then you can sort of like fold around, try to find where that is an equilateral triangle with itself. Like there, yeah, you can sort of see it there. Boop, you can just fold there. That's pretty cool. So I think that's pretty cool. So this is the same height, root 3, and then 1. Well, the 1, the long, and then root 3 over 2, the short. So these two get tucked. And then this folds in half like so.
Can you just do that again?
This one?
Yeah, open it from this full rectangle. Yeah. Okay.
And so what we had is first we did this pretty much. Like when we did first, it was like this. And we upper right came down. So instead of it falling on top, what we want is to be within. So I'm opening it and then sort of pushing it within. Like that. And then this little guy that's here, that dude gets tucked underneath this side hinge door thing. And then it comes down the same thing. And then that one gets tucked on the other one. So both of these are tucked. And that folds right between.
Folds in.
Well, where I call this the slit. So that's where it sort of like looks cut. And now you fold together. And so what you do now is then where this line ends, you can see there, this you fold back. And this one you fold back as well. So it looks shaved and clean and nice, and you turn it over. Same thing, and this one goes back like so. And this one goes the other way, like so. And that's your piece. So I have here some that I've been making.
Oh.
So this one actually a pretty cool way of to make a dodecagon. I have them united in units of 3. You can actually put more, like you can make it be 4. I've put 4 together at one vertex. I haven't tried 5. You probably can do it 5. Let's see how these combine is. So you get one of them, and then you sort of put it within. Although we're gonna do it again on the other piece we got, so we can put it together. I'm just gonna put this into mine, because I'm impatient. So then when it comes together, like this flap that's excessive is gonna go into the other side of the thing when it falls in half. So this triangle is gonna fall on this side, and then this bit is gonna fall on the other side. So that's also what sort of holds it together. You can also like open it a little bit, and then it's gonna tuck within.
Oh yeah.
And there you got your, it's going to start to shape and whatnot. So we're going to do one more, just to recap. We have our little square here, a little shape. We fold it in half like so. We open it. We go into the quarter. Yeah, the dodecahedron, that's correct. Although I find that if you could combine more pieces around the vertex, you could do more shapes, but it's very natural to do a dodecahedron or a cube, because those are the ones that have junctions of 3 at a vertex. So if you wanted to do like an octahedron, you would need to make units of 4, so connections of 4. If you wanted to make an icosahedron dodecahedron, as well 4, because an icosahedron dodecahedron goes pentagon, triangle, pentagon, triangle. So that's 4 connections. So in here, it goes pentagon, pentagon, pentagon. So that's 3. The cube goes square, square, square. So that's why that will work with 3. So, okay, we have here the triptych. Upper right down, rotate, upper right down onto the line. Making sure that it's spiky there at the corner. Open. Descend. Make sure that it falls exactly where you want it to. As a side note, we don't really need this rectangle to do this. I just think it's great because it has the proportions that it's gonna, that it's using. But you can make this from any sort of rectangular shape, because what it's based on is these junctions, really. So this could be as extensive as you want it to. You know what I mean? Like you can make the same shape on this big one. It's gonna be longer. I think it's gonna be less stable, but you could do it. And then Francis Howe has like a whole series of different angular connections. So instead of it being like a 60-degree connection as it is here, it's like a 90-degree connection. So that means that instead of going like this, like we're doing, he is folding all the way to like a square. So it's actually like junctions of squares. What's interesting is that it works. This is my finished unit. So now I can keep on putting it onto my shape.
I guess the classic is the 5 intersecting tetrahedra that too uses a module by Francis Howe.
Yeah, exactly. Actually, when you say that now, it makes me think that what would it be like to like make intersecting dodecahedrons? You know what I mean? Like nothing's stopping us from making a lot of these and sort of like making them be like going through each other. Maybe then it would be useful to have a longer sort of rectangle for the unit. Maybe instead of using this one, we could actually be using this one.
The reason it works for the tetrahedron is because it's its own dual. The edges would pass through themselves and it doesn't work.
Oh, I see. So then what we have to do is then make an icosahedron and then it would be able to cross. Maybe. But then it would actually need a bigger, because then if we use the same length and just sort of cross it, then it would sort of, I don't know. No. I would need a little change, a little modification there. That's interesting though, to think of how to intersect these. So you can see it starting to come about. It's pretty cool. And see, here's how it would look like if I made a square junction at this point. So that's just to say that this could be also like a great drafting board for solids. You have your unit, you know that how many times it connects, and you can play around with where it connects and what shapes you get. And it won't be always convex, like it'll look like an egg sometimes, but that's fine. Okay, we got 30 minutes left. Let's see. So, okay, the corrugation. So the corrugation uses the crisscross lines, the herringbone, as a basis. So I'm going to use my other rectangle I have, and I'm going to get it to be crisscross. So it goes from one corner to the other, and one corner to the other. So what this one needs is to be a higher resolution shape. So we need like the same thing, but now we want more of these divisions. So what helps me sometimes is to have this triangle cut in symmetry. So actually like have some lines that cut into this triangle to help me orient myself. So I'm going to fold it in half, but it looks like it's folding in half, but what I'm actually thinking about is having a line that goes right through the triangle. So now because I want to go through a triangle, I also want the line goes through here. So I'm putting my edge of my triangle onto the edge of the triangle. And it looks like I'm putting my corner into the center. And so now I have the lines of symmetry on my triangle, so that's good, that's nice. And now I can keep drawing the lines I want to, lines I need. So I want this angle which is the same as that angle. All right, let's break it down. So let's do a little bit more down here. So let's make more triangles. So let's do the one that goes through here. So that's going to look like corner to corner. Now the other corner to corner. So here we can actually get a sense for the motif of the pattern we're going to do. So this is a herringbone tessellation. A herringbone is pretty much just like these crisscross, one on top of the other. There's no offset, there's no gliding. It's just same crisscross, one after the next. But when you do it by folding, what you do is you first do one of these crisscross and valleys, and the next one in mountain. So these are going to come in mountain, right? And then the next ones, this line, I come by, well, mountain. These are valley, and then this are mountain, and then the next ones are going to be valley. So just to keep an eye out for those sort of crisscross lines inside of this rectangle. The second step for this one, just on the chat. Okay, so for this one, what we're doing is pretty much just keep tessellating it, just keep marking the same triangles inside. So what I did first was get my triangle in. So we started with this line, goes from corner to corner. We started with that. So then I got the other line that goes from corner to corner.
Yeah, got those two.
So this was one, and then there was the other. That's how it started. And then I noticed that it was my triangle, which was, and then what I wanted to do was actually draw a line that was cutting the triangle in its midpoint. So I wanted to do this line. So I folded the edge onto the edge, and then got the whole thing. Same here. So it would look like this. So it's corner to the center, that one. And now what I wanted to do is just finish this off in a way, you know. This one actually goes all the way. Same thing. And now looking at, well, this one actually also crosses all the way. And now it's sort of missing something here. So what I did was just finish it off, and then I went also from here to here and here to here. And then I think this one we didn't have, but it's, you know, might as well. So now we have a center of 6. So it's a hexagon. It has these triangles on the outer edges of it. And so inside of it, we have these zigzag lines. So I'm going to turn it over so you can see the zigzags. Just to recap, these lines that we drew in at the end are if we fold the thing corner to corner like so. We turn it over. And this is the motif. This is the basis of the pattern we're trying to do. So now what we want to do, there's 2 ways of doing this. You could do it the easy way, which is sort of like folding it and then applying the fold, or the hard way, which is sort of like applying force to it in a very strategic and precise way. But let's focus on what we got. So we got these zigzags are made of these rumps. And now what we want to do, so you can see sort of like the strips of rumps, right? You can see how this is rump A, this is rump B. Over here we got rump C, right? So the lines we want are drawn from point to point like so, point to point like so, and point to point like so. But all these lines I'm drawing in are going to be mountains. So I'm just going to draw them in by folding. So it's just corner to there, It also looks like that, funny enough. So that's what's cool about this rectangle. It's full of symmetry, full of symmetry. See how it's falling there? And then the last bit, this last triangle thing. That one falls on there. So now we have this triangle here. It's going to come down, but for it to make sense in this outer one, we also need to see how this point is like this point. So that means that there's, at this point, if this is like this, we need to draw as well a mountain for this triangle that goes down there. And that looks like this. Get this out of the way. So I think one of the harder things about this is not to lose focus. Like, keep your eye on the prize, keep your eye on the ball. So this is the motif. It's pretty much just having a triangle underneath another triangle, and then if we kept repeating this, then it would go on and on and on. So we're gonna open it. And now, so we saw the motif, we saw what we want to do, we saw what we want to repeat. These rhomбs, these crisscross, and then drawing sort of these mountains between them to make triangles that sink and sort of falling on itself, and they become flat. So instead of having a pattern like the one we did before, which is like this, which is flat but on its side, it's not flat, when we open it up, we have now one version of the same sort of sequence, which is actually flat spread. So we wanted to keep this going, we need to have more crisscrosses. That means more divisions, more, and so on. So let's see where they are. So they're always going to be parallel. So we have some line here, then we could just fold these in half. There's an idea, or we could fold at this sort of intersection there. It's a parallel line like so. Or we could fold there, which is actually, I think that's a half. That's a third. That's interesting. Do that, corner to there. Next one will be there. Boop. Now it's here. I don't know if this one has a name. It probably does. All these origami patterns tend to be coined and phrased by the time we do them, but we don't always have the names of the authors, and that's fine, because I think that who we really are working with is sort of God. I don't know. This is my way of sort of coming close to God. This is, yeah, it's just nature, right? It's just the universe itself. It's life itself. It's the way things are. It's the way that they've been engineered to be. Not engineered to be, because it's not like it's mechanical. But there are rules, like there is something which applies always. And folds tend to sort of showcase some of that nature. And a lot of the basic designs, especially the elemental ones, if you will, like the herringbone, they can't be really coined by somebody. They can't be really owned. You can't own a pattern. Tell that to Penrose, right? But they're there. You know, the pattern don't need you. The pattern is just what it is. So now that I have my grid there, now I just need the lines to go through the half of it. So for instance, it would be here. So what's cool about this division I did, instead of preferring to go for halves, I went for thirds. And the thirds are very sort of natural to the hexagon and these divisions. It's, if you don't see it, go for halves. It's like halves are very natural to this because it's a 6 and 3, you know, it's there. Thirds are also accessible. They're there as well. So now I have a much higher resolution thing of the same sort of sequence. So now I can start to play around with how these are about. So for instance, now my pattern is going to look like this. Pop, pop, and then bounce back here and then bounce back there. Now, what I have to do as an origami person right now is make sure that the lines are where they need to be. So that means that I have to sort of rearrange the circuit in such a way that this collapses and makes sense. Or, you know, we could do that first step, or we could just be like, all right, you know what? I know what I want to do. I know that I want to do the motif, and I know that it's where these sort of shapes come about, and I need a mountain that's there. So I'm not even going to bother with the circuit. That's something I'm inside your brain. You know, you can think this way. I'm not even going to bother making the collapse first. I'm going to put in all the lines I want for the pattern that I'm looking for. So you could, you know, there's several approaches to the thing, which is what's cool about it too. So that would be the herringbone. And now it's about, you know, mountain, valley. But we have, like, you know, this is what I was telling you about. We have these columns. And now what we wanted is that here we need to draw these triangles. So there's a triangle, and then, yep, there's a triangle. Here's a triangle. Here's a triangle, and here's a triangle, and here's a triangle. So we have to install all these in order to get the pattern that we're looking for. Or we could just go for the herringbone. So tempting. Let's see how long this takes. Well, it's easy when you draw in the lines, because if not, it's so easy to get lost. So I think the lines actually are beneficial to us as origami people, as folding people. And there's always something new. So that's also one of the cool things about teaching, is that somebody's always going to have like a fresh take on it. Like, no matter how good you get, no matter how much you fold, there are some things that you just don't see because you're you, and you can't look at everything. And nothing holds as many deep truths as the basic stuff. So it's cool to sort of refresh these things every chance I get, but also to see what other people do with them. So the bigger challenge of teaching origami is to convince people to try it on their own, to try, like, hey, you know, explore, see what you find. Because, you know, people want results, and when you explore, you won't always get results. And that's a bummer. Or is it? You know, it's how you take it, it's how you look at it. But, you know, a lot of people, that's why they, you know, they follow instructions. And I mean, I'm probably responsible for people not wanting to ever pick up a piece of paper to fold it again. I can see how in my early days of teaching, somebody's going like, screw this, like, this guy's crazy. I don't know, not like crazy, but like, no, I don't understand what he's saying. I'm not jiving with it. Like, nah, screw origami, I'm not touching it. I could see that happening to me, or like to somebody else, because of me. That's why I try. That's why I keep trying and try to better myself and be clear and sort of do the things that I say I do, and keep people hyped and keep people in the loop and whatnot. And, you know, just to make a case that there are these infinite possibilities for designs, and that they might just find one. And yeah, it's not all in books. See, it's like that Shakespeare quote, you know, when he finds his dad, or was it Horatio? Like somebody finds his dad, or like his dad's a ghost, and he says something like, you know, there's more in the world than we can fit into our philosophies, or something like that. Like there's more to the world than our philosophies. So no matter how much we write or read about history or other people's insights, the world is much more. And what's cool about origami is that the world is in your hands when you fold. Like it's right here. You're folding it. It's happening. So when you follow instructions, it's like you're having a map. It's like you go out on a quest to the universe. You go out with a map. You sort of, you know where you're going, and you find. And that's cool. It's really cool to have maps, to have guidance. But I think what's cooler is to use the map and then sort of like explore inside of the map. So you have your map, you do the map, you're like, all right, this is the result. So where can I find something that he didn't tell me to find? Because it's not over. Like, you know, it's alive, this thing. So there's a lot of possibilities yet to be uncovered. And you just might be one who does. So I got lost in my motif, as you can see, and now I'm going for the crunch, for the old scale crunch. It's gonna spiral out into a... And why am I following it? Because it's calling to me. I don't know. It's what's happening. But you know, I feel a little disingenuous now because now we're doing the motif. We did all this thing and for the triangles and whatnot. But I feel as though I may have made a mistake. Because in the original one, there wasn't. So where's the original one? So because here there's actually a cross added. So I don't know if I did the other motif like jump in another one, like as though there was one that wasn't used, or rather maybe this one's used for the sink, and then the one next to it is the one. Oh yeah, that's it. Yep, that's it. Boom, that's it. Boom, like it's nothing. Like it's nothing. So it is cool to sort of like install the different functions of it and then play around with that. So because of time, I'm going to put this aside just for now, just a little bit. I'm just going to finish this motif. I'm going to put it aside for a little bit. I'm going to show you how to fold an Islamic pattern that I discovered yesterday, which I find very beautiful. And I think that it has a lot of potential as well for some more uncovering. Because something that I really like about Islamic patterns is the possibility that within them, there's another pattern. And sometimes it's the same pattern. Sometimes it's like a variation of the pattern. Sometimes it's a whole different pattern. But that's what really is quite interesting to me. So when you do it by folding, and just in this way, like we went into the scale of it, you know, we kept like having the same pattern but only smaller, and then you can sort of see different relationships come out. And also this is what happens when you use pencil, your fingertips get messy. Yeah, so you do it by folding, and then the possibility that you can find where it's going to lead to is quite, you know, in your face. Okay, just going to put in the motif and then move on. I say it like it's so simple, but yet, you know, what's hard is not to put the folds in. What's hard is just to put it to the side. That's what's hard, to stop folding. That's what's really hard for me. I can't stop. Does that happen to any of you? Not yet. Okay, not yet. I'm going to take that as a not yet, maybe, perhaps, but trust me, like, if you do this enough, you're going to look at your watch one day, it's going to be 3 a.m. and you won't know how that happened. That was last night to me. Somebody's saying something, but I can't hear. Sounds like a message from beyond.
Oops.
Is somebody speaking right now? There's like a background noise for somebody. Because somebody's speaking, I can hear only static. So type. If you're speaking, I can't hear you. I don't know if it's my microphone, my speakers. But if you're not speaking, then, you know, ignore this message. Now they're screaming. So I'm going to try muting people and see who it is. So it has to be... Yeah, it's Ashima. Are you trying to say something, Ashima? I had to mute you because I couldn't understand that so it kind of freaked me out. But if you have something to say, I'm reading the chat. You can type it in the chat. I'll unmute you. Oh, I see. Well, I did mute you and the sound stopped, so I don't know. These things that happen, I don't know. Sometimes. So yeah, weaving. Ah, no worry about it. No, I muted and that seemed to fix it. It's all good. I sort of like kept wanting to listen to see if I could uncover some secret message. But alas, there was none. Okay, no, yeah, I gotta stop now. This is sort of the idea though, like you get these triangles so you can sort of crunch them like so. And then the bottom triangles would also like do the same. They get tucked. But I'm looking at it. I think I'm missing a crucial piece because this should also be tucking. Oh, I see what I mean. Oh, yeah. Yeah, no, it's going to take forever. No, I'm kidding. It won't. But I do feel I need to move on because there's a bunch of stuff that I still want to teach you. I want to teach you an Islamic pattern. So I'm just going to put this into nothing. Put it down. One last thing. There's another way to do it.
Did you fold horizontal lines?
No, now I know it's definitely me. Like it has to be something wrong with me because it can't be that everybody's having a problem with their system. Let's see, I'm going to try on disconnecting and reconnecting my microphone. See, my headphones, sorry. All right, try speaking now.
Sorry. Did you fold horizontal lines?
Yes, I fold it horizontally. And well, just to sort of like accentuate on these, which is the same. This is the herringbone, but now I'm just sort of like concluding this for now on the herringbone, and from the herringbone I'll take it to the next level. But first I'm gonna sort of like install the herringbone, and then from there take it. So instead of actually trying to shape it from nothing into the finished piece, I'm gonna go step by step, the way it should have been. So you can totally see how this is also a nice circuit for it. No struggle, folds quite nicely. And that's the advantage of folding it horizontally too. You can sort of shape it as you collapse it. So for instance, yeah, so that's it. So now I have the bottom zigzag there, so I can just sort of push at the pressure points. And then this will change direction. Just sort of shape it. Yeah, you could totally fold new triangles inside of this. Totally. I think this is still big enough for more divisions. It's still a workable division. Like I think this right here is a satisfying amount. Hold it in your hand, you can definitely tell. But like the more triangles you put into it, and the higher the resolution, the more amazing it looks, and the more flexible it becomes. And that's when you really like get something that's amazing. Because when you have this multiplicity, it's several things. It's like your eyes can't seem to focus on it very much, and you sort of like just travel it. And also it shows that you were dedicated enough to like work it for a long time. So that's also what people, I think, are drawn to. It's like the idea that somebody was so dedicated to something that they spent like a whole evening, a whole day just doing something, or a whole month, right? In certain cases. It's interesting because the other times I've folded this has never given me a problem. And that's not necessarily giving me a problem, but it's like, it doesn't want to come down the way I want it to. Sort of getting in the way. No, that's the way it is. You see, that's just the way it is. Yep, that is the way it is. It just goes up like that. Now that I'm looking at it, it is totally the way it is. Because what it wants to do is sort of fall like, oh yeah, totally. Oh, were you maybe talking about the triangles in the squash? Oh yeah, definitely. You can find some more squashes there to sort of accentuate. See, this same thing, I transformed to this one. So it's the same sort of design, but just differently ordered and pressed and pulled at different points. But it's sort of one of those, it's a circuit. This one is accentuating more on the hexagons and having this like spiral of them, but at the same time, one is going to the right and the other one's going to the left. So this one's receiving, but this one's giving to it. So it's nice. You can actually see that I have with the lines there, the herringbone line. So there's a lot of opportunity for play and experimentation, even within this very simple grid. So that's also an incentive. That it's not just like when you finish something, that's something that's not an animal. Although animals tend to have this phenomena too, but like usually if you fiddle around with it, you will find either a better solution, a deeper solution, or something you hadn't even thought about before, which is completely different. And that tends to happen in origami all the time because it's a very, very powerful tool. And so you don't really need to understand it to use it, which is one of the things that I think a lot of people have a hard time understanding, me included. Like understanding it doesn't necessarily open the world to you. Sometimes understanding it can even close the world because you're like, no, it has to solve in this way. But if you're just doing it, it's still there. It's still in your hands. You know, you can just have fun. Yeah, I wish my microphone was working. I don't know why, but somebody's speaking right now. I cannot. It's sounding like static to me. I think it might be it's not my headphones. It might be my system. Sorry, guys. I'll see if the recording also picks up the static as static or if it's actually recording proper. Because it's weird to me now that it's actually... So yeah, it's weird to me. It's not the first time that happens. So we did it. We did it.
Wow.
So now for this one, what you can do is on this side. So we just pop one of the columns like so. And pop the other side as well. This one was the one I discovered yesterday. Usually what I would do for this one is just like uncover different run by, but then it turned out that you can do this. It's pretty sweet, pretty nice. And then that becomes your new motif, see? You can keep it going, make smaller ones, make more of these, different pops, different like pixel art kind of situation. It's amazing. It's really versatile. And when you're done with it, you can just press the points and then it becomes shrinkable again. Okay, so we're the 2.5 mark. So I know that I said it's going to be 2.5 hours, but I do want to teach you the Islamic pattern. So I'm just going to do it. If you want to stick around, welcome. If you're not, send me a message reminding me to send you the recording. I'll send it to you. You can skip the times, do it on your own time. You can pause it. You can mute me. Something that's exciting. You get to put on your little music and stop hearing my rambling. Which I don't know how I do it. I don't know how I keep talking for 3 hours a day. I don't know where I got so much to say. So, new thing. This one's going to come about from the square. So we're going to use the diagonal for this one. So you can be confident in folding the square shape. You can use these strips to make some of those tessellations, some of those, modulars. There's several modulars on the Discord, so be sure to join the Discord so you can see different designs. There's a channel there called Folding Resources, and it's full of academic papers, instructions, and other different useful stuff. And I know it might be daunting, it's a lot of stuff, but I think it's worth skimming through it, see what you find. So for this design, we're going to fold 2 corners. So these 2 points are going to be centers of our pattern, okay? So we're just going to be using the eightfoldness. So we're going to bisect each of these. And we're going to see how the other corners. All right, I don't know who's talking, but I can't understand. So I'm just going to mute you. I'm sorry. I think it's Ikram, actually. Oh, that means it's Sharmina, isn't it? Sorry, Sharmina. No, I'm still hearing it. What? Is it me? No, I'm not hearing it, so maybe. I don't know. I'm getting trolled. No. I'm kidding. So, okay, 2 centers. We open. We do the same on the other side. We're bisecting. And so this one's going to have 2 stars on each of the 2 corners. And there's going to be a barrel between. Okay? But we're just going to sort of use each of these lines as references for the star. That's pretty much what's going to happen. Okay. We're going to fold this in half again. And now this one's going to go the other way. Like so. Now we're going to do the same thing with bisecting, but now at the other two corners. But we're going to turn it over first. So notice how what I'm bisecting is different on two sides. So this one is going to be, so this one's a valley, but the other one that I folded for the earth division is a mountain. So that's something to keep an eye out on. We're folding these two in the opposite direction. So one's folding one way and one's folding the other way of the sequence, of the pattern. See how even my diagonal is different? So in this one, my diagonal is a valley, but here my diagonals, well, sorry, this one's a mountain and this one's a valley. See, my diagonals are different, which means that my bisections are also going to be different because my bisections are going to be complementing. So if this one's a mountain, next line is going to be a valley. So same on the other side. So they're interchanging. So I said that this point right here and this point over here, those two are going to be the centers of our shape. And we're going to use even the radial lines as part of the pattern, but they're not going to be stars, they're not going to be centers, but they will shape our star. Here's the initial part of it. So it's a rather small pattern, but again, like the idea is a possibility of scaling it further inside. So can you see sort of like the star that's going to come about? So what we need is the same line, but we want it to draw. So not the same, but rather we want this line to mirror and fall and connect where this one does. So this one's a valley, we want the same to be. But because we're doing it opposite, it's going to be very convenient for us because now we can use this mirror, see? Because they're opposites. So this one's going to be working as a mirror line, this one's going to be working as a ray of light line, a light line. It's easy. And then once you do that, you can then sort of fold that down and you're going to see that it's actually a very nice relationship. This corner falls where this one falls. So where this one falls, this corner falls. So again, these two are touching. So if we wanted to just hack it, we just go for now. So these two get interchanged with these two. Now I'm going to fold this to there because before we did the other one, right? So we can skip the mirror trick. If the mirror trick is too daunting, too weird, too much, you can always do that. So same on the other side. Corner to radial line. This is actually an origami trick. Like you're going to see several, like if you go into several animals, they use this division for their animals. Some of them do at least. I think the rabbit by Donald Coe uses one that's very similar to this. Like that rabbit, I love it because it's so eightfold. Not even knowing, like I doubt this dude knows about Islamic patterns much, but it's funny that his design for a rabbit seems like one. So now I'm completing the star that I was telling you about. And now that also completes the torso, as somebody rightfully corrected me and called it. Right? The shape of the stars there. But now this one's going to go continue all the way, but we don't want just for this line to continue all the way. That's kind of boring. So we want to sort of install a channel here. So by doing that, well, what I mean by that is that we're going to sort of like this same width, we're going to copy it over here. So this same width copy. So what we do is we fold one, we fold two, and now we have this excess. See? And now we can use that as, and you're going to see that those two coming together, that corner is going to touch. Now send me a message on Instagram and I'll send you the recording so you can catch up and also go over the lesson. and do it on your own time. And thank you very much. Pleasure to have you. And yeah, be sure to join the Discord. Don't forget. See the one way. We do that the other way. Yes, going back. You can also start to see like something's gonna come out of there, like a new scale, right? So the idea is we got our torso, we got our star, but now this pattern is not usually continued by just a straight line. Not usually. Usually what happens here is this like house shape, and this house shape has mirror symmetry, bilateral symmetry. So we have half of it. So we can just get first that fold, then the other fold. See? These. And now I want a mirror. I want the same width, but on the other side, because that's what bilateral symmetry sort of indicates. And when I do that, there's some sort of nice relationship. So it falls right on there, right on that corner, that point. You see how it falls in the line that I have? And besides, that other corner falls exactly where that torso tops. So, those sorts of relationships sort of make your brain feel nice, and you're like, I can appreciate this. I can dig it. Let's see what's next. And sort of when we fold Islamic patterns, that's what we're looking for. We're looking for those sensations. We're looking for that sort of symmetry, that underlying solution, which is nice and precise. And just, So we have a choice here. And I think the choice kind of does for itself, but I like to do this in a spinning fashion. So one needs to complete all the way, and one needs to like partially complete. So I'm going to do, this one's going to go completely, but this one is only going to go partially. So it's going to hit there and then hit back like so. So you see how that's complete my little house, but instead of having this one be another house, I'm going to have it be coming from the other way. So it's like a spiral thing. So that way only one of these goes to the corner and the other one doesn't. So that looks a little nicer. And this will actually work as a tile, like for tessellation. You can actually like place this next to another one like this one. So a very simple design, very elegant. But now when it comes to like making this a 3D shape, which is also what's fun about folding these patterns. Now let's try to find that. Let's try to find how to make it 3D. So I'm just going to show you the example that I did yesterday. For this one, where are you? Here it is. So as you can see, there's many more folds in there. Ignore this. This is unnecessary. This is hard. But we can shape this guy. I think to shape the torso is important, and to shape the stars is important. So, okay, notice how the star has an 8-3 at that corner. Oh, yeah, no, I understand. We're 15 minutes over the time. So, Chuck, if you need to leave, again, send me, send me a message on Instagram, and I'll send you the recording. And if you want a private lesson also, send me a message. We can set that time up. And yeah, because we're like teaching this to so many students at the same time, we're just going over the lessons as they come along. So it's different designs, different things. Sometimes it's harder, sometimes it's simpler, but it's sort of, it's in the same vein. So also, if you want to feel like you want to catch up, join the Discord and be like, you know what, I want to do a basic class. And if some of the people there are like, I want a basic class too, we'll get you all together, get you a time, and we'll work on that. So yeah. Thank you very much, and I'll catch you on the next time. Great to have you. So now we want to do for this one, either this goes right through the middle there. Does it go through the middle there? Yeah, it should. That's funny, it doesn't look it. That's so weird. Like you look at it and you're like, nah, this line doesn't cross like through the center, but it does. It's crazy. Okay, so we're gonna put, okay, so one of the things about folding Islamic patterns is that all the lines of the pattern always, like all the examples I've done, like they're valleys. Like when you want to crunch them, they're always valleys, the lines of the pattern. And now what's fun, or like the trick, is trying to find the rest of the sequence, the rest of the circuits. So that's what's funny. That's the funky thing. Like all of these lines are going to be valleys as I have them. But now it's like, all right, try to find the mountains and the valleys that compensate for them in the rest of the sequence. So let's make a mountain that goes from here to here. So I'm going to turn my paper over and I'm going to fold this in half like so. And I'm going to fold the other half as well. And see, when we want to do this, we're going to find that at certain points, more divisions are going to come up. So at this point, for example, it's going to start to radialize. It's going to be more divisions coming in. And what that does, it's sort of do what happened to our pattern before. So there's going to be suggestive pieces. Somehow more pieces are going to come up to us. And that's what's interesting about it, that you can sort of start to look for and find new patterns. So we just added these two mountains in it, and now we already see some life in it. It's already starting to come in. Using these valleys and then these mountains, it's already starting to happen. And then we have the same thing here, see? So it's another barrel on this side. So taking that into account, we can either bounce it off or try to find this line. But see, we need this line anyway for the point that goes here towards the center. This has to be a mountain, just like it is here. See how that's a mountain? Because this is a valley. So valley and then hits mountain, but because it's bilateral symmetry, you also need a mountain that goes from here to that corner. And that's going to be very useful because it's going to cut right through the middle. Because it is the middle, we have now the point where we want another mountain. But you see how this sort of like compounds, always like, oh, this one suggests the next one, suggests the next one, suggests the next one. And you sort of keep going forever. And so now the next one would be here, and you can find that that one falls right on it. This line falls right on this, right on that, so you can see right on the fold. So this is one of those complementary folds. It's one that makes your brain feel nice. You see that? So now we've got this shape. But see, it's not complete because we need a line that goes from here to the center in a mountain. So we also need one that goes from here to here. So I'm sort of like looking for those 2 points, that intersection and that intersection in mountain. And I find that this line hits this rhomb, and I can see that this one is starting to look like one of those torso looking things. And well, if you wanted to compensate, actually make like a little shape here, like a square, we could just either use a mirror, so we can do this, use the pattern as a mirror line, which is also what's pretty cool about it. Then we can, like, it's all part of it. It's almost like, this is what convinces me that it's much more than what these patterns seem to be. Like they are something else. There's some underlying undescribable thing that's at play here. So now I'm just gonna finish this torso that goes from here to that point. Now that I have it, now it's gonna be a mountain. And see, the corner falls in the center there. So all these new hacks, all these new tricks are like, all right, so that one goes there, that one goes there, that one goes here. So another compensative. And another compensative over here. We can use that one because they're going to be, it's probably going to happen on this side as well. But see, a very basic pattern can then be full of details. Also something I love about it. because it's one thing to use the folds as a drafting tool to draw the pattern in. That's pretty cool. That's nifty, especially if you haven't done it before. You're like, oh damn, I didn't expect this. But then you start to fold, like, to make it properly origami, because usually people with origami, some of them are kind of snobby, and they're like, oh, that's not the proper thing. I can hear them in my head, like they don't say anything, but I can hear them. Like that's not a fold. That's not really folded. That's really just some lines that you folded in and you drew them in. But where's the pattern, man? Where's the fold? And so the answer to that is, well, you got to fold a little bit more, and then you can find the sequence inside. And it's there. It's there for you. And yeah, then the origami snobbies in my mind, they go like, oh yeah, well, I guess they are. Sort of settle down. It's funny because like I heard in the Eric the main class, like he's going like, oh yeah, we don't use cuts because that would make it too easy. It's like, oh no, we want the challenge. We are folders. Like cutting, excuse me. It's too easy, man. Please stop it. I don't know, but folding is hard. Like the cutting and folding is hard. Like in my experience, it ain't no walk in the park. So now this one's starting to come to life, but now there's one detail about these sorts of designs that it never sat right with me, and that's the stars. The stars always seem to sort of like be in the way. So what I resolved for that is to add a smaller star at this corner. So right here, we're gonna add an A3 star. We're gonna do the slimmer version. So it's several ways of doing this. The way I can do it is just by folding this and put in there. Or we could just, at that point, just a perpendicular. Because all the stars of a shape always are part of that shape's sort of symmetry. You can find that one also there, one of those feel-good folds. So all the stars are within the divisions of their circle. So what that means is that the angle that makes the star are the same angles that make the division of the circle into that particular shape. So in this case, for instance, we're just working with the eightfold, so that's pretty, straightforward. But see, now what I'm realizing is that this fold needs to be a mountain. Well, why? Because the next fold is a valley. Why do I know that's a valley? It's part of the sequence. Like the circuit demands it. The pattern, the Islamic pattern must be all in valleys. Therefore, what's next has to be a mountain, because if it's a valley, it won't do anything. So I need to change this up a little bit. And see what this allows is that now you can see a nicer effect. See, now the flower, now the corner there is sort of like falling down, but it needs to be complete. So I now need to sort of either go that way. So I'm going to do that. Go this way and then go that way. So like do a mirror trick. And it's going to be a fold that's nice and neat. We can sort of take advantage of. What's cool about the mirror is that usually this happens too. Like when you do the mirror, there will be relationships that if I take the mirror off, those relationships are no more. Like there's another one. But isn't it interesting though that we take away like a specific angle of it and then sort of like translates it into another point that's like, it's on the same line. It's this one, then to this one. Well, it makes sense if I look at it that way, because it is this slice that's being taken away. So oh, wow, I hadn't looked at it that way before. God damn. Got my mind blown there for a second. So now just to finish it off. Oh no, we need one more. Now you see this, now it's sort of closing a little bit better. See that what that does also is it gives us advantage to sort of like craft it into a lock. And now whatever the sequence is will sort of be tightened and sustained by this star that falls there. So it's a very also like it turned out to be this very neat way of locking the thing, which was unexpected at the first time. First time around it was pretty unexpected. So now we just need to finish this off with the back there on the boop. And it's good to start like with this, making patterns 3D with the smaller one, like this one, like with a more, not that resolute image of it. Because as you can see, there are many folds. And this is just what, like 1, 2, 3, 4, 5. Like these two are partial pieces. There's only 3 complete pieces in this thing. And still look at all these folds. Like, oh, well, of course, all these are partial. We could just add these 2 up and that's a full one. You could add these 2 up and that's a full one. But what? We're still working with 3, 4, 5. This is not even like full. This is half. So what was it? 3, 4, 5 and a half. And this little bit. So what? Another quarter. So yeah, not even 6 pieces we're working with. And look at all these folds. This one goes right there. And see, I'm looking for intersections, see? I'm looking for intersections. I'm wearing a headphone that I was going to put music on and I forgot to click play and I just got into the class and now I've been wearing it the whole class and it's starting to bug me. I don't know why I don't just take it off. I'll tell you why. So I'm a masochist. I think that shows up in my folding too. Alas, there it is. See, what's cool about crafting these locks in is that the rest of the shape now sort of like gets a crunch. So everything just kind of like, oh wait, well, because these are spiky, they, you know, it has a hard time staying put, but we can just do a little thing here. It could even work as sort of footholds. And now what I'm suggesting is that if we take this apart, this same thing, so we put in the 3D folds, everything's nice, it looks good. We take it apart and we try to find more pattern. We will find one. Like there will be a smaller, different version of the same pattern within these structures. And if there isn't, we can always use the ones we do have, the partial ones, to craft the full thing. So I think that covers everything. We did a heptagon, which turned out to be, you know, didn't turn out to be much of a figure in its own right. The Islamic pattern that I was trying to do for it turned out to not be the shape that I needed. But it was a lesson. It was a great lesson, at least for that. And then we also saw how the lines from these stars and the apothems can combine. And even though we, you know, well, there's this shape too. We can always just do this. There's this guy on Instagram called Win Origami. He's been doing these shapes recently with the, he's doing these quarantine posts.
It's a girl. She.
Oh yeah, no, it's me. It's me. can't hear you either. I don't know what I did. I'm gonna have to restart my computer after this. Win is a girl, yes. Okay, sorry. Win is a girl. Yeah, she is. Sorry. But anyway, she has been doing these quarantine posts, and she's great. She's an amazing folder, and she's doing these things where she's gonna do these sort of like tucks. She's gonna have these like excessive bilateral symmetrical shapes and sort of like putting them together and then sort of like tucking them away. And she can make all these different maps with it. And it's quite beautiful. It's quite intricate, nice. And, you know, she's cracking it and she's making all these different things. But I guess you could always do this, right? With it. So we looked at the heptagon, constructed it regularly, which is awesome. It's amazing. Loved it. We did the silver spiral, like the golden spiral, but we cut away at it. Interesting. It's full of something. It's full of it. And what else we do? Oh yeah, I didn't show you the possibilities of making a pattern like this. This one was actually hard to crack. Sarah helped me quite a bit. But yeah, I think it's not even like it was, but it was interesting how this pattern actually came about using a sort of relationship of the stars, like combining, putting a point from the shape onto the center and the apothem onto the center. And that offset it produced was actually part of the pattern. So that was quite fun to sort of see how folding can then come about through there too. But yeah, that's not to do with the gold, with the silver spiral. We did the geometric construction with it. That was nice. That was fun. We did this thing, which is the hexagonal corrugation. It's a cool one. It allows for these sort of weird popping in and out shapes. You can go like 1, 2. You know, you can make these rums. Or you can make triangles, so you can sort of like pop them at will. You can make a strip of them and then a strip knot and strip, and you can play around with this. This is a fun one. And so we saw that. That was fun. And we also did the Francis Owl shape, which I'm on the current. You need 30 to make a dodecahedron. I'm on my way. Probably gonna use this as a lamp and give it to somebody. I don't know. The structure is amazing. Like it really holds really nicely. So what I'm thinking for this one maybe is like using a piece of paper, maybe cutting out a pentagon like we've done with the constructions, with some other paper, something that's translucent, and just pasting it here, right? Or maybe even just measuring these lines, making a hexagon with those lines, taking away one slice, having a pentagonal pyramid, putting it inside of here, pasting it, and that would be the same angle, I feel, this right here. So that's also another thing. Then it could look like it's steep, or something that goes inside, or it's like a little pyramid that's offset. Play around, make it that pyramid pop out. I don't know. Looks fun. Something to think about. What else we do? Finally, well, we did this Islamic pattern. No, this is not the one we did. We did this one. Same one, but you know, that's not the one we did today. And this one, we actually made this one 3D. We worked through it. We made it 3D. We sort of like, yeah, even though there are very few shapes in this pattern, this could actually be tessellated quite nicely. If you do this in a smaller piece of paper, something that could actually fit on tracing paper, you could play around with rotating it and putting it into a sequence and, you know, have fun with it. Also is the possibility of finding another pattern, which is similar to this one within. And looking at it, you know, I claim that, but I'm looking at it, I'm like, where are you? Let's see here. So I know there was a star that I saw. Well, I'm also noticing that there's this one. So same lines, kind of. But again, this is like at the same scale. It doesn't seem to be the point I was trying to make, that it was like a smaller one, but it's also like a pattern, you know, it's an Islamic pattern. And it's here. It has the double square. It has a double square. It has this half square after it. And then it produces these shapes. But yeah, my advice is that on the Discord, if you want to like a basic class, just put in there like, hey, I want a basic class. And then somebody's going to be like, hey, me too. And hopefully. And then we can sort of like set a time around you guys so that we can do it in groups instead of going one by one. And, it's fun to have somebody else with you there going like, oh, yeah, I don't understand it either. Me either. And then, you get to talk about that. All in good fun. Now, this one is something that I would actually go the other way so that it makes me the cross, and then this one comes out as the shield looking thing. See what I mean? So then that could be a line I'm missing. Yeah, why not? Why not? Right? Why not? Why not just go ahead? Just do it. Interestingly enough, this pattern that I'm folding here is actually also all in valleys. Now, why that is interesting is because on the other side, this pattern is also all in valleys. So what this suggests is that when we do the shines, is what I call when I make a 3D, when you do the shines, so that everything just like becomes a 3D shape of itself, those shines, which are mountains, if you turn them over, they could actually be the pattern that you're looking for. So that's neat. I didn't know that. See, we're discovering stuff. My oh my, I can sure extend the class, huh? See, now that looks more like a pattern. Now, if I'm not mistaken, this one would be part of, so if we put another one there of this one's, this would be the shield, and this would be a cross. Here's our 2 stars, it looks nice. And now what I'm inclined to try is then, well, with this opposite pattern on the side would be, well, what if I made this 3D? What if I find the lines that make this one? Will that produce on the other side the lines I'm looking for it to be on the next scale? And I think the answer is I don't know. But see, now that I'm looking at it on the other side, which is with this channel going through it, it is striking. Because now what I see is I have this little house there. Well, I'm going to draw it on the other side because that's where it's a valley. I have this one, and then, well, it looks like it extends, and this one is as well. They don't usually match like that. These, well, whatever. Let's see what happens. So now that like that, so I won't be so inclined as to have the same thing copied, but you can see that it's like one of those strips. And we do have, what do we have? We have the possibility of adding more. See, now you just keep going and going and going on forever. Try to find more pattern. More shapes, more shapes. And you can sort of see, well, this is the top hat, if you will, of a star shape. So there is that. And goes duck, duck here. So yeah, this is my suggestion to you. This is what I want to leave you with. The idea that we're not done. The idea that somehow there's more that has not been seen before. And that with enough time, dedication, and effort, you too may be the first one to do something. Because see, as much as I'm, doing this folding origami with Islamic patterns, no matter how much I fold it, I will never, ever, ever be able to make them all. So that's also why I wanted to teach them, because more people have to do this in order for all the patterns to sort of get made. And I want all the patterns to get made. I want it all. No, I'm kidding. I don't know why. I thought it would sound funny. Now I feel bad that I assumed Win was a girl, was a boy. Don't tell him. Tell her. Another shape that's sort of like wanting out to me is trying to find where. See, I have this one. So almost like, you know, the one that's like a tower. So it goes here and then goes out. And so I need just the line that goes back in order for this to complete into this strip shape. And see, that will make more sense because then I could actually draw in across here. Maybe a little square here. No, it wouldn't be a square. Actually draw a torso here. That'll make more sense. This would also be a house. Make more sense. Like a house after a house, maybe like a strip of houses on this line. That'd be cool. Yeah. Meanwhile, on the other side, we said it's just a very simple pattern. It's just the torso with the houses and the star, and that's it. The big deal. It's all coming in from the sides too. It's bouncing off. It's very natural. It's very fine. And then you turn it over. It's like, poof, what is this? Fun times. So what do you guys think about the class? You had a good time? Hope you did. Me, I had a great time. I have a great time folding, and I'm glad you guys like it. Be sure to send me a message so I can give you the recording, and so you can do it on your own time with your own rules. And yeah, you can go as slow or fast as you want it to go. You can also fast forward to different exercises. And yeah, if you feel like it, if you want to, you can always donate or become a Patreon on Patreon. It's cool. Yeah, it's cool to have you guys here. Hope you had a good time. And I'm just not gonna stop, but I probably should, because life needs to go on. But wait, I saw one more. See, this is why I get to sleep until 3 a.m. because I'm just like, oh, one more. I saw the thing. That's the line of the pattern. I'm sure of it. And sure enough, like I'm usually correct. Like that is line of a pattern. But then so what? You need to rest, man. But the patterns, man. Yeah. Yeah, there's a torso. See, now I don't like this. I usually like for my lines to continue or not. Well, yeah, not. Yeah, that's good practice for the lines to keep going. So all this has to go away. Just make it a star. Either bounce or don't. Either bounce or don't be there. Yeah, no, glad you liked it. Glad you had a good time. And just in case, I'm just gonna put on the chat the PayPal. Just in case. Just in case. What? No. I have to put in www or HTTPS. Guess I do. Oh yeah, also remember to download the file I sent you. Well, if you join the Discord, you'll probably see it there as well, but it doesn't hurt. There we go. Just in case. No pressure. See, now this is making more sense. Now you got the torsos. It's coming in on this. This one looks kind of weird because it's sort of like coming in it's coming in a little strong, I feel. So maybe not the best choice. It's sort of, it's not actually continuing from here or anything. Rather, we need a shape that either touches the whole edge of it or it's not there at all. I mean, this can look nice, but not with the torso here. We need something else. Something to complement this house. We do another torso. Yeah. Well, that also leaves us with this square, which is sometimes part, like the square can be a shape in its own right. Also, I've seen they do little houses in a square in the middle. That could be a thing. What I mean by that is we can then like draw a line like to compensate for this channel, like do a channel on the other side almost. You can have this square, you just compensate for that, and then you have, house, square, house, play around with that. Maybe there on this strip we could do this shape. One's like a square, √2 square, and then little bits on the top. We could find that here maybe. Maybe it's here. That's the square. And it's going to be the √2 and then the square. Maybe it's another scale, so maybe it'll change it too much. I'm more inclined to sort of try the other torso and another star here. I can see the star though. I can totally see the star. I'll show you. Also good to try pencils and not pen first. I drew with a pencil first and then with the pen, and then you can just erase the pencil. Pen remains nicer. Probably the same thing with the Islamic patterns, right? See the stars here. Just now we continue. Nice, more symmetry. We just need a line here. This intersection, and this line usually has a little square there on the corner as well, so you can always keep an eye out for that. Just making sure that the things intersect, things go through their respective lines. This line will go on itself. This one will also go on itself. So there's a bunch of those. This one meets here, meets there. All good and nice, all nice and good. You could also work with partial stars. So instead of actually completing this star, we could always sort of play around with this partial thing. So for instance, this one could just be one of those shield looking things. And try to draw around options, but no. We actually have a cross here. If we've had another, like if we tessellated this could actually be the quarter of a cross. So that's pleasing, that's nice. A star here, we can actually play around and make something else on this side. That's also an interesting concept. The idea that, these patterns are sort of interchangeable, or you can find new things within that one does not suggest the other necessarily. We do need another torso there. We need to change that into a star. So this is gone. This is gone. At least we're going to keep the torsos on this on both sides, but then we're going to see if we can match something else. Try to find some new shapes. Besides the obvious star that's sort of already popping out of this, but we will want to keep this going on. So the lines keep going, lines keep going. Let's see now. I mean, again, and not necessarily, like if I wanted to have this piece there, I could make it be there and then make the rest of the pattern fit what I want. Like I'm in charge, you know, like I got to remind the paper that it's, you know, I'm putting the piece where I want it to be. Sometimes we are following like tradition and following, you know, the sequence that's laid out there for us. But see, now at this point is the center of a star. I actually have to include, like if I wanted to make a 3D, include the whole eightfold rotation around this. Did Richard leave already? Oh, I missed the chat. Oh, man. Oh, yeah, that was like 5 minutes ago. I'm lost in this. This is all extra. So I did the thing I said I didn't want to do. But why? See, I'm noticing that if I put in too many of these torsos, there's going to be necessarily like a little square here. So if I put a torso here, it's going to give me a square. Right on, Tsunabi. This point becomes the center of this shape. But yeah, now we've made another pattern. And yeah, the idea is that further we could find more patterns and keep this going. Yeah, it might seem crazy, but here it is. I'm missing this line. I guess today we're going to leave it at that. I'm going to look for more patterns on this. I'm going to keep it going, make it 3D, have fun and whatnot. And yeah, so yeah, be sure to check out the Discord and send me a message for your link for today's class. I'm also going to be posting these on Patreon. So that's the initiative, right? So put it on Patreon. All the classes are on there. And just $5 a month. That's the idea. But like part of me is like, just give it away, dude. Just let the people have it, man. But hey, gotta have some incentive, right? At least for now. Maybe I'll make it public later. In a month or something, I don't know.